Am I on here twice? How do I get rid of this? Maybe I'll just sign out and come back in. Let me do that. There we go.
Hey, Don. Dave, how you doing? Dang, I lost my mind for a minute. Oh, well, I was in there when you were talking with Don over there, and he decided to leave and come back again. I had Don on my mind. Anyway, hello, Mendoza, Randy. How you guys doing?
Hey guys.
Hey there. Look, it's George.
Hey, Randy.
I tried getting rid of it. I have no luck.
Are we blessed or what?
You're blessed tonight.
I guess.
Hey, Dave, did you say Don is on your screen twice? He's only on my screen. Oh, I see where he's at. Yeah, he got his picture and a name.
Ken says hi, everybody.
Hello, Ken. Let me see.
It just said he don't Zoom.
I had somehow my streaming software was screwed up, and I had to add my own microphone.
How's that?
It's only on YouTube. They didn't hear me until just now, but that's okay. Now it's working, and YouTube should be up. Yep, YouTube is working.
Here's your partner in crime, George.
Why did you want to call Sam my partner in crime, Randy?
What crime did you commit?
Hello, peoples.
Ooh.
Oh, it's Snipper.
Hey,
Stiff's back with his screaming.
Guys.
You still got, is that the Golden Gate Bridge? I thought it got tore out. I saw it happen, yesterday on a movie.
Oh,
was it King Kong?
No, it was an earthquake, and it was an earthquake movie or something.
Oh, okay, yeah. Well, yeah, crazy. Well, we're going to learn about, vertical dipoles tonight, right?
Yeah, this guy's got his own design.
Yeah.
3 or 4 of them, I think.
Yeah.
Is this Fong?
Yeah, Ed Fong.
Yeah, yep. Ed Fong.
Okay.
Edison Fong.
I've been looking forward to this. I heard he does a very good presentation.
Yeah, I'm looking forward to it. That's for sure.
Sam.
Oh, there's Ed. No, WEJM, the other Ed. Hey, Ed.
There he is.
I see are you muted too? No, okay. You have to unmute yourself. I have it set to mute automatically.
Sam, are you in a closet?
There's
Never
Craig.
Would you come out of the closet, Sam?
We only see half of your head, Sam.
That's good.
Oh, there we go. That's better.
Sam's got to get his tights on with his shirt with a big S on the chest.
That's it.
There you go.
He's got the cape somewhere, don't he?
Shadow knows. There's no problem. Okay. I'll be back in just to look in a tad. If not, it might take 3.
No sweat. You've got 25 minutes. Then the show starts. That's when the show starts. I hope that's iced tea and not bourbon, Ed. I'm just kidding.
Well, it does help the meeting along.
Yeah, that's true.
Patience is everything. Yeah.
It's Friday. It's been a long week. Let Ed have his drink if he wants.
I think it was iced tea. I recognize that.
Yeah.
Water in the bottle.
It's iced tea.
Same. The bourbon bottles are shaped that way sometimes.
Yeah. Today wasn't quite that bad.
How would you know, Dave?
What's that?
I said,
How would I know? I'm experienced. I like the stuff with the big plastic bottles. Cheap. Just kidding.
The Stater Brothers special.
Yeah.
You know, the box wines are coming back in.
Are they popular again?
Yeah, they're very popular.
They used to have beer in a box years ago. They had these beer balls. They were like 5 liters, I think, if I remember right. They were maybe more, but they were like a big box. So inside was a cylindrical plastic ball, and then they came with these little taps you plugged in, or you could buy the tap separately, I think.
Was that like Genesis?
St. Stan's. Do you remember St. Stanislaus is the name? That was the name of the brewery in Stanislaus County somewhere.
Huh.
We're talking the 90s. It was before the big, craft beer revolution.
Genesis used to have a little plastic plug that was in the bottle.
Yeah, they have the gas in the bottle. Or can. They have cans that way too. They call them widgets. And when you open the can, it opens up the widget, and then the nitrous goes in there. Nitrous gas adds more bubbles. It's just like draft. It's pretty good.
They try to recreate draft.
Yeah, it's pretty good. It's really expensive though.
Yeah.
For what it is, I mean, I don't know.
When are you going to start manufacturing Our Lady of Sun Lakes?
My own. Somebody donates a brewery to me. I will.
Our Lady of Sun Lakes.
Yeah, you know that other one, St. Stanislaus.
Say Stanislaus.
I like that one. Our Lady of Sun Lakes. I think that's great.
I don't think the name's going to stick. Sorry.
Probably not. That's great.
I'm sorry. Randy was trying to ask a question. Serious one, probably.
I was going to say, well, you got a spare bathtub, don't you?
Yeah, actually I do.
Yeah, but you got to be in the gin.
That's actually where I do my fermentation. But not like you might think. I put the container in the bathtub.
How you doing, Ed? Good to see you.
Well, doing fine. How are you guys?
Pretty good. Pretty good.
I'll be right back. I'm blinding myself, so I got to get a hat.
There you go.
I was thinking about that. I couldn't find one that would fit on my head.
That's funny.
Too much hair. Oh.
Gentlemen?
There's Jeff.
Well, Jeff.
Mr. Secretary, sir.
There he is.
K6CA. Hello, Jeff.
Mr. Jeff.
Hey, Mike. Craig, KN6DMW.
Oh, yeah. I forgot to mention. I don't think he has a camera. He showed up last month.
Oh, okay, yeah.
Department of Motor Wagons.
Don't start thinking about phonetics. That's a bad way to go. It can get dangerous.
Well, that's true.
DJ, are you out in your trailer?
Yes, I'm out in the desert.
Oh, you're in the desert. All right.
Hey, DJ's remote. What are you? You're using a hotspot?
I'm using a hotspot, and it's 20.
Your audio just bugged out, DJ. Weirdly.
Yeah, it's 20 over 20 on a hotspot.
Oh, okay.
And you guys are all frozen, but I can hear you perfectly.
Wow.
Oh,
Okay.
wow.
So
Yeah.
you're not getting a good video anyway, but
What part of the desert are you in?
Yeah, where are you at?
Ocotillo Wells, or Truckhaven.
yeah.
Right.
That's where Sam grew up.
Well, close to it.
Used to drive by all the time.
Hey, DJ, is that a hotspot through your cell phone?
No, it's a standalone one. I borrowed it from my sister-in-law. She has a good one.
Uh-huh.
It's a lot better than mine. So mine didn't work at all here, and she brought hers.
What does it connect to? What does it connect to?
It's some type of cell service, and I don't know.
You're using your phone for the camera?
Yeah. No, I'm using a laptop.
Oh, you're using a laptop. Okay.
Yeah, and it's connected. It's one of these.
All right.
I have no idea what it is.
It's basically a cell phone radio with a Wi-Fi.
Yeah, it works.
A router, basically.
Yeah.
No idea what it is, but damn, it's good.
Yeah, it works.
Cell phone router. I have a friend that lives in an area in Oregon where that's the only kind of internet service you can get.
Yeah.
So he has that. And basically, all of his phones work off that too. He's got 2 channels, I think. Okay.
So what's been going on, George?
Not a lot. Just a typical Lent Friday. That's it. Went to mass this morning.
Oh.
Went to Stations of the Cross, and then went to lunch with Mike and Gail.
All right. I went and got my second shot today.
Oh, how you feeling?
Still good.
All right. Very good. My second shot's scheduled for the 10th of next month.
Right. Yeah, yours is coming up.
Yep.
Hey, Sam, did you get Moderna or Pfizer?
Moderna.
Okay. I've known a couple of people getting Moderna and they got feeling kind of punk after the second one, but you're an ex-fireman. You'll ride it through, I think.
Well, I put this one in the other arm.
Oh, okay.
Oh, that makes a difference. That'll
I don't
even
know.
it out.
I thought we'd find out because I've had a couple of pretty good ones that, they said they had trouble. SOI.
Yeah. My second one kicked my butt for a couple days.
Really?
Yeah.
Oh.
Was it a Pfizer or Moderna?
Moderna.
Moderna.
I think that's all you can get in Riverside County is Moderna.
Is that right?
My first one, it's Pfizer, and I didn't notice anything different.
Somebody said their arm hurt.
Forearm.
Oh, yeah, okay. It was Jeff. That's right. Jeff had it.
My shoulder hurt on both of them.
Right shoulder really. It was really sore, but it wasn't anything that wasn't a problem.
I didn't have any problems whatsoever other than I just knew I got a shot. That was it.
Pete got hammered by his, didn't you, Pete?
Yeah. The next day, I was in very bad shape. I didn't sleep all that night. The next day, I had aches all over, like I had a bad flu. I was nauseous. I had a headache. But, it all went away after that.
Wow.
But if they're not injecting you with any chunk of the virus, like common vaccines, what the heck is making you sick? It's just the chemical that they're shooting in?
No. It's antibodies that are built up in your body from the first shot.
I see. Gotcha.
Now the body recognizes it and it starts fighting it.
I gotcha. Johnson and Johnson, in the paper this morning, Johnson and Johnson claims they're coming out shortly with a one shot does
one,
all.
Yeah.
They claim it'll be better, more effective, but
I talked to a guy that was on that. In fact, talk to him every morning on a rag chew, and he got the Johnson and Johnson. He was part of the study group.
Oh.
And, he said it was fine. He just every week he had to go back for blood tests. So, but he said it didn't have any trouble at all with it.
Oh, that's
good.
Who was that, Randy?
Ben.
Okay, I thought that's probably what it was.
Finn.
Yeah, he said, "Oh yeah, I didn't want to go back for the second shot." I said, "Well, heck, you went back 5 weeks."
You were already a pincushion.
Sorry, Earl, I have it set to automatically mute, so you got to unmute yourself.
Hey, Earl, how you doing?
There he
Hanging
is.
in there.
There he is.
Boy, you're getting a stack of junk back behind you.
Yep.
Look at all that gear.
Yeah, boy, look at that.
That's what happens when you own an antenna farm.
That's right. They start breeding after a while, you know.
Yeah, lights,
Yeah, I know.
lights are blinking off and on and everything. God, it's
Yeah, I don't know. That's interesting.
like a Christmas tree.
You got your antenna lit up, DJ?
No, it's still in the bag.
Okay.
Okay.
You gonna try?
So let's see.
Are you gonna try and play down there?
I'll maybe later tomorrow.
M2 antenna systems.
Nice.
Huh.
Hey, beater.
Hi, Edie.
Hi, Edie.
Hi.
Hello, Edie. You can just push him out of the way.
Yeah.
Used to it.
Tell him to share that screen with you.
Right.
All right.
I must be tired tonight because there's George sitting there and I've got no snide remarks for him.
Yeah, I think you used them up the other day on our Zoom meeting.
I must have had.
Yes, you did.
Yeah, I'm sure you'll think of something, Randy.
I'm hoping. I got to start taking notes. This is terrible.
Yeah, it's not like you to be nice, Randy.
I know. No. Well, like I tell everybody, you hate me now. Wait till you get to know me.
There you go.
Ed, how's your business picking up?
Yeah,
How is your business
Business
picking
don't-
up?
Does his business ever
COVID
change?
hasn't slowed anybody down.
I don't think his business was affected too much. I could be wrong. Yeah, you had to work at home for a while, didn't you, Ed? You told me that.
Yeah, I'm still 2 days at work and the rest
Oh,
of
okay.
the
Yeah.
rest of the week at home.
You notice an increase in activity?
It kind of cycles, so nothing really drastic.
Really? Okay.
What kind of business, Ed?
It's government.
The kind you can't talk about.
Yeah, right.
I'll shoot you if I can.
Yeah, they have to kill you.
Hey, Ron.
Good evening, neighbor.
Here's Ron.
Hey, Ron.
There's
Greetings, everyone.
Steve's iPad.
Well, Ron,
Yeah, there's Steve's
Right.
iPad.
Email from my email, and it didn't do it.
Well, there's Steve
Oh,
himself.
there's Steve. Wow. Okay, there. He's
In
full.
the person.
I sent him a message that he has to unmute himself.
Yeah.
But
And Craig. Do I know Craig? I don't think I know Craig.
Craig's been on. He's here for the meeting last time, but he doesn't have video or audio.
Used to come to the meetings.
He's just He's watching us, but he can't. He doesn't have a camera, so or a microphone probably. So that's okay. And yeah, there it is. Craig just sent a text,
Hello, Craig.
and it says hello to everyone
I'm
from
glad to know you can
KN6DMW.
too, Craig.
He can type.
It's tight. Well, he's got me beat.
Hey, does anybody know if HRO up in Anaheim is walking in business, or are they still curb only type stuff?
I think. Well, last I checked, they're curb only, but you might check our website again.
I think the website still says it's curbside, but why are they doing that? California's allowed them to open, and they're just still doing curbside.
Because they're. It's run by a bunch of old men,
I
that
think
are
so.
high risk.
Well, that
Hey,
solved
how
that
about-
problem.
So I mean, isn't it obvious? I mean,
Yeah.
you've been in there
Some of us
before, right?
resemble that.
I know, really.
That's no county for old men.
What are we gonna buy, Flip? What are you buying?
Oh no, I was gonna pick up some cable. Maybe I'll be up in Orange County tomorrow, but I was just curious whether.
Yeah, you could just call them and they'll have it ready
Yeah.
for you.
No, I know.
I think that's convenient because I don't like to hang out. Otherwise, I'll buy more stuff.
Close the door. Just close the door. Oh, really? Okay. All right. Yeah, crazy.
So when Ed starts up, we're going to do. Well, I don't know if you got the message or if you read your email, but he's going to start the program. So or the meeting. So we're not going to do the regular meeting stuff till after the program. And when Ed starts up, I want everybody to mute. We don't want any noise. If I hear anything, I'll mute you myself. So,
Are you going to fill the screen with him?
Yeah, he'll be full screen. I'm trying to figure this thing out still. It's got something called speaker view, but unfortunately, it still bugs out sometimes if somebody else talks. So that's why I say just make sure. Yeah.
Hello, Mike.
D1.
You look grumpy today.
He's muted, so Mike, unmute yourself.
Mike's muted. I'm sorry, Mike. I should have sent you the unmute.
There,
Oh, there you go.
There you go. Now you're working.
Okay. Good evening, everybody.
Hey, Mike.
Thank you.
How you doing?
Okay.
George said he had lunch with you the other day.
No, today.
Today, that's right. Today.
Friday.
So Friday.
Yeah, Jersey Mike's.
Wow.
Nice.
Good sandwiches.
Their Philly cheesesteak with jalapenos are to die for. Well, will die.
Isn't that the one they have here now, right? Right across.
Yes.
Yeah. Is that where you went? Oh, okay.
Yes.
Yeah,
I'll figure it out.
But I highly recommend that one. But like I said, you're cholesterol city right there.
Yeah.
I went by In-N-Out on the way home and had mine with the animal fries.
Wow.
Animal fries.
Sam. Remember, it's supposed to be turkey sandwiches.
Did you take your VW Bug through the drive-thru? I love In-N-Out.
Yeah. Sam, what's animal fries?
It's smothered with chili and.
It's got
they're little zebras and donkeys.
It's got
chili and cheese and all that other crap.
On the fries?
Yeah.
It's heart attack in a bag.
Oh, it's delicious.
Yeah, it is good.
Well, you leave them in the bag and it soaks up all the grease, so then they're healthy.
Pete, there's a secret menu that is not
published.
You got to ask for it. You can even get sautéed onions on your
yes.
hamburger.
Oh, really?
I read about that too.
And they are delicious, by the way.
Then there's the 4x4, 4 cheeses and 4 meats.
And then you can.
It's got more mustard on it, something else. I forget what they all are now.
And then you can get just a burger patty between slices of lettuce if you wanted. You can ask for that too.
That's way too healthy, Flip.
It's called what?
That's way too healthy.
Way too healthy.
I totally agree. I never order it. I never order it.
That's what my wife gets, the protein.
Yeah.
That's a hard way to live.
All right. Yeah, if he doesn't show up on schedule, we'll just start doing little things. And
Yeah, he'll be here.
but he'll be here. Okay. I'm sure he's reliable.
Hey Dave, when you host a Zoom, I'm doing one with about 8 or 9 people. When you host it, I've never done one. Does the control board come up differently where you can control things, or you have to load something different?
It's basically the same. I mean, it's pretty much the same. There's some controls at the bottom that you don't have on the regular. I mean, unless you're hosting, like recording and some other things.
Oh, okay.
You can share screens,
yeah,
or allow other people to share screens. But there's a lot to it. There's a lot to it that I didn't even understand until I started poking into it further. But
yeah,
pretty versatile.
Sam, were you on 72 this morning?
72. No, sir, I don't think so.
8, okay. Because Mike was feeling under the weather. I was just wondering if you knew about it.
I talked to you about it on 50, the other 72.
Oh, the other 72, yeah. I got the lower 70.
Are you guys talking in code?
Yeah.
It's okay. I guess we're not on the air, so it's okay.
Okay.
Yeah, it gets confusing now because one of the rag cues is on 3972 and the other one's on 3872.
Oh, geez.
Then there's 3888 in the evening.
That's the only one I know about was 3888. Okay.
Jerry showed up tonight, though, Sam.
Which one?
Jerry, FLY.
FLY. I'll be damned. Good.
We're hearing you. We're hearing you, Earl.
Anybody tried out 60 meters?
That's
Not lately.
yeah. I was gonna say 4 years ago, maybe.
You know, there is a net on Saturday morning at 9:15 on Channel 1. There's a San Diego emergency net or something that ran on that. So you might try to tune in there.
Yeah, I made 5 contacts on it.
Did you? Oh, cool. So did you build an antenna, or are you using just one of your multi-band?
It's an HF antenna, long wire.
Did you build it just for 60?
No, it's multi-band.
Multi-band. Okay. Cool.
Yeah, that's the only action I've heard on 60 though, is that one net.
Yeah, it's towards the bottom of the band.
Yeah, and it's like 9:15 on Sunday morning.
9:15.
So Earl, did you just pick one of the channels?
Basically, I just put it on scan, and one guy was in South Dakota, the other guy was in Kentucky.
Wow.
Because that band is only like 5 different channels. You have to stay in one of those.
Yeah, they're channelized. All the radios basically are limited to only those channels.
Yeah, I think it was.
But if you haven't updated your radio too, you might want to update your radio because they changed some of the rules about 60. Specifically, I think total output power is more is allowed. So your radio's behind. You could just reprogram it that it should be smarter.
Yeah, it was at 5.322.
Cool. Got Larry. We got coming in. Larry, you're muted. I don't know. We can't see you because you probably don't have a camera. But you're muted. If you want to, you could just click your mute button. But we're going to mute up again when the speaker comes on. Should be soon. Getting close to 7 o'clock.
25 seconds.
Here he is coming.
There he is right here, I think.
Look at that. He's running Windows 7. Oh, we got so quiet all of a sudden.
I know. Everybody's waiting.
We're at the starting gate.
Oh, we're waiting. Oh, here we are. Okay. Win 7 PC. I don't know if that's it or not, but whoever it is. I guess we're waiting for your audio and video. Somebody's drumming. Is that Flip?
Can you hear that? I'll be darned.
You know, your microphone's maybe the most sensitive.
Oh, okay. Let me play with that for a second.
I thought it was a drum roll.
All right, how about now, Dave? Is it
Now,
still
there's
the same?
Bill with 1 L. It's a little better.
Okay, I just turned it down quite a bit.
Yeah, because you were hot.
Yeah.
Bill, turn on the lights.
There's Bill. Wow, Bill looks like he's out on a party patrol or something.
It looks like he's on the lot. He looks like he's on the Las Vegas Strip.
Yeah. That's what I mean. Okay.
There we go. I'm in my Jeep, and I'm in the city of Hemet.
Oh, okay.
And I'm just about to leave, so I'll be driving the whole time the meeting's going on.
Okay, make sure to mute. I'll mute you if you don't mute yourself.
Yeah.
That's fine. And we're still waiting for the speaker, although I'm not sure if it's what's going on here. We've got somebody trying to connect.
Okay.
And then we're going to go right to the program when he comes on.
Looks like you're having a rollover, Bill. Are you doing it Tiger Woods?
I thought Randy was bad.
Hey now.
Hey now.
Well, you know, Flip, if I had the choice, I'd avoid me too.
Oh, whoa, Randy, that's terrible. Talk about bad luck for Tiger, huh? Holy cow.
Yeah, huh?
Jeez Louise. It's
Yeah.
one thing after another, it's just one after the other.
I don't know how you get into a single car wreck like that, but
I don't either.
I think he's going too fast.
he had been going too
Probably.
fast.
Yeah.
Somehow ended up in the other lanes. That's pretty weird.
Oh, there's our speaker.
Oh, there he is.
There we are.
Ed.
There's Ed. Okay. All right, I'm going to make sure everybody, go ahead and start this off, I guess. We're ready to go. It's 7 o'clock.
Ed's got to unmute himself. There you go.
Okay.
Oh, there.
Hey, Ed.
Well, I got to change my name because I've got my wife's name on here.
Oh, okay.
Better change it, right? Someone said here, rename. There. Hey,
Yeah.
question here.
Sure,
that
sure.
I have you guys down as I'm supposed to give the tri-band talk to you folks. Did I already give you the dual band talk?
No.
No. DJ, are you still
Nope. Nope, this is the first time we've ever
there?
had
Yeah.
So you really should get the dual band talk.
Let's do the dual band.
I mean, are you guys pretty familiar with how a dual band antenna works
Too. Yeah, I mean, sure.
with the
Resonates.
stub and everything? I mean,
Yeah.
I'm not sure everybody is.
No, I think we should go with the
yeah,
dual
usually
band.
that's the first
Because,
talk.
yeah, most of us are definitely antenna novice, so.
Okay. Yeah, let me give you the regular talk then. Yeah, that's the first one. The second one's usually the tri-band talk. The third one is usually how do you get gain out of a J-pole.
Well, it's
And then-
definitely, it's best if we have an excuse to have you back, so.
Probably. So, okay, so let me get things ready. So you guys have a meeting first, right? Or
No, actually, we're going to go ahead and have you go first.
Oh,
I'll
really?
Go, yeah, because we don't want to waste your time with our meeting.
Okay, hang on. Let me get my stuff. Well, why don't
So
you
whenever
start
you're
with
ready. Yeah, we'll go ahead and start.
Yeah,
Maybe
let
we'll
me
do a
get my
roll
stuff.
call, or we'll just do a roll call. Okay, guys, I'm going to go ahead and we'll do self introductions real quick. I'm Dave, KD6ZJZ. I'm going to go from the left to the. It's the only way I know how to do this. I'm trying to think there might be a better way. Maybe we should do it with the roll call, the real roll call. I have a copy here somewhere. That doesn't matter. We're not all on that anyway. Okay. Let's just do this. Randy, you're first.
Hey, some of you might know me. I'm Randy, K6RJA, living in the spleen of Beaumont.
Okay, I'm Dave. I'm KD6ZJZ. I'm the second person on the screen. Okay, Mike, you're next. Mendoza.
I'm Mike. I'm KK6BUW. I'm club treasurer, and I live in Beaumont.
Thank you, Mike. How about George?
Oh, me?
George Humphrey.
George Humphrey, W6GRH, and I live in Ukaipa.
Thank you, George. And then Don, who's called Ham.
W6UW, Dom, and I live in Ukaipa.
Thank you, Don. And DJ?
I'm DJ, KJ6UUS. I'm currently here in Ocotillo Wells for the weekend.
Maybe I should go for the solo video. Well, that's not going to work because then I can't see who's who. Sorry. All right, now how about Flip?
I'm Flip, K6WM. I live in Banning, and I'm sitting on my back patio right now with my view in the backyard on the 9th tee.
That's a nice picture. Very nice picture. Is that actually you on the back patio?
Yeah.
Oh, that's cool. Ed, EJM.
Ed, W6IQN, located in Banning, and I'm currently the vice president.
All right. Thanks, Ed. And Sam, you're next.
Sam, KI6NME, also known as D3. And I live in West Banning.
Past President Sam. Okay, then Jeff Burris is next.
Jeff, Kilo Bravo 6 Charlie Alpha, Secretary.
Thank you, Jeff. Ed's the next one on the list, and he's going to get his stuff, so he's still not back. And Steve, you're next.
I'm Steve, NJ6LN, and I live in the north end of Banning.
Okay, and then next we have Craig, who doesn't have video. Craig, KN6DMW, and Larry. I'm terrible with call signs. Who remembers Larry's call sign?
KE6MAE.
Thank you, Larry. Larry, you can speak for yourself. Thanks, Larry. And somebody called WinPC, and that might be 17PC. I actually think I might know who that is, but I'm just going to keep it to myself because I'm not sure. And you could text us Win7PC, but otherwise, don't worry about it.
Hey, Dave, I
Yes.
think there's a text out there.
I saw a text. That was Craig. That was Craig. Let me look at the chat again. Craig says, Craig, living in Sun Lakes. Okay, so Craig wanted to make sure everybody knows that he lives in Sun Lakes. And so...
I don't waste too much time.
We're almost done, basically, Ed. So you're... Larry, we're hearing you. Okay, Larry... Did Larry introduce himself? Larry?
I zipped.
Okay. You're really loud, by the way. Okay, I'm gonna mute. Everybody's gonna have to mute, so you guys go ahead and mute up. I'm gonna go ahead and introduce Ed. So I'd appreciate that if you'd mute up. If I hear you guys making noise, I'll mute you myself. So
you forgot to let me introduce myself.
Oh, I'm sorry, Bill. I don't know how I missed you. Maybe you snuck in, probably.
I'm Bill Seymour. The call sign's WA6MOD. Celebrating my 50th year in amateur radio today. This year, rather. I am the Net Control Wrangler.
Yes, he is.
And I'm in my Jeep right now in the city of Hemet. And while you are giving your lectern, I'm going to be listening to you while I drive home.
All right. Well, it's going to be recorded on YouTube, so I already sent out the link. If you want to watch it after the fact, you can do it that way as well. It's being recorded right now. Actually, it's live on YouTube right now.
You want me to introduce myself?
Yes, Ed. I was going to introduce you. Why don't I introduce you, and then I'll let you introduce yourself if you want more. Oh, I'm sorry, Mike. I'm sorry, Mike. I missed you too. And did I miss Ron as well? And I missed everybody. It's my fault. Okay. Pete, I think I missed you. Did I?
Yes, you did.
Go ahead, Pete.
I'm Pete. I'm in KJ6NRR in Four Seasons, Beaumont.
I got ahead of myself somehow. Earl, did I miss you?
I think you did.
Earl?
Kilo Mike 6, Sierra Papa Yankee, Earl Valvista, and Edie.
Edie is right next to you. She's also a member and also a ham. Edie's what's your call sign?
EMT.
EMT, right. Okay. Ron, I'm sorry if I missed you. You're next.
Yeah, Ron, KG6SOI, West Banning.
Okay, now Mike, UIJ.
Okay, and I'm Mike, WA6UIJ, southern part of Banning, and I'm in my 60th year as a ham.
But he missed a few years because he had let his license fail and they had to come back, get it back. Oh, well, we got Bill already taken care of, so I think we're done. So Ed is currently at the faculty of Santa Barbara and Silicon Valley Extension campus, where he teaches wireless communications courses. He's an inventor of the TBJ1, the DBJ1, Delta Bravo Juliet 1, Delta Bravo Juliet 2, and the DBJ UHF antennas, which are extremely popular amongst the ham and commercial community. This is right off his website, by the way. And he's got a few articles in QST, and I sent you guys an email with more specifics about that. So go ahead, Ed. Why don't you start your presentation for us?
Okay. Hey, I love your background, Dave.
Thanks.
That is cool the way you have it set up.
No problem. I
How
love
did you
it
come
too.
up with that?
That's actually built into Zoom. I came up with the picture, but you can select whatever picture you want and have it behind you.
No, I know. No, your picture, the way you have it configured, like you're the captain of the
Yeah,
starship.
exactly.
That is really, really cool. That's the first time I've ever seen that. Okay, thank you. Well,
No problem.
that looks pretty cool, I have to admit. I got to tell my wife about that one.
Okay, thanks.
So let's see. We're going to do a share. So I can share, right? Okay.
Yes.
Disable the share. Let me share.
I'm sorry. Let me do that.
Okay, you got to let me share.
Remember how to do that. Where's Ed? Oh, Tina just dropped in, by the way. Allow.
So I got to do that, Dave. I got to get the picture of the starship and then do a background. That is really neat.
I could send you the picture if you want. I guess I make you the host. Is that the only way? How do I do this?
No. Somehow you can give me permission to share a screen.
Okay, I'm not seeing it.
Because
try
I
maybe
can't
this
do
here.
it right now.
Oh, here we are. Here we go. Try that.
Okay, now?
You should be able to.
Okay, good. Got it.
There you go.
And there, you should see it now, right?
Yep, we see you now.
Okay, we got it.
Great.
Thank you very much there, Dave.
No
And
problem.
you guys are in San Bernardino. I haven't been down there in about 15 years now. I got a few friends there.
Kind of between San Bernardino and Riverside.
Yeah, I know exactly.
Yeah.
Bad traffic area. I know that area.
Yes.
Bad traffic area.
I'll mute myself. I'll let you go.
Anyway, hey, thanks a lot, Dave, for inviting me and everybody else. I'm Ed Fong again. Yeah, I teach at UC Santa Cruz up here, not UC Santa Barbara.
I'm sorry.
And I'm getting tired of all the Zoom. I teach all my classes on Zoom now. So I'm in charge of the RF wireless group. And I teach an optics class and a high-speed I/O class. And I used to teach more circuits classes, but I don't anymore. But they got me going with Zoom, I tell you. Anyway, here's the first of our talks. And again, thank you for inviting me. It looks like you guys have a good group there.
Thanks.
So, I've talked with several of you folks down there. Let's see. I'm sharing the screen here. So do I need this anymore? Hang on. Sure. Extra TV. What is this? This is really weird. I've got my other screen. I've got somebody else's screen here that I'm seeing. I think it's yours, Dave.
Well, I don't know how that would be.
That's not my screen.
That's too weird. What are you saying?
Okay, we're sharing. Can you hear me, Dave?
Yes, I hear you. I see your presentation. Oh, I'm sorry. Hold on. I'm sorry. I muted myself.
Okay,
I see your presentation. I'm not sure.
But I see your screen. I see someone else's screen.
You are
here.
viewing it. Oh, I'm viewing your screen somehow.
So somehow your screen came on here from Zoom.
That's too weird because I'm seeing your screen.
Yes, meeting controls. Yeah, I see you moving the meeting controls. So how do I get rid of you?
Let me just stop sharing if I could do that here somehow. Stop. I say.
Oh, how about exit? Do I exit here?
I think I stopped. No, wait, hold on.
I see your desktop.
Let's start this over again.
Yeah, okay, now your desktop went away. What did you do?
Yeah, I went to one at a time. Let me see.
Okay, now you're cool again. You're good.
Here we go. Only one at a time, all participants. I had to go into advanced sharing to fix this. Now try it, Ed. Sorry.
Okay, now share the screen. Oh, that should work. There. Okay.
There we go.
We're back. Okay. Anyway, so I was saying I teach about three classes right now. Not at any given time. I think I'm assigned like 4 classes a year, but we have fun. We have a lot of graduate students, and keeps me busy though with the Zoom. Good news is I don't have to commute. Bad news is I'm always on Zoom constantly. So you're seeing our little studio we had to set up here with, I've got a good USB mic and camera and all this stuff. So, okay, so let's get started here. This is the first of our talks. And you know, the other thing, everyone's asking me to prepare a talk for the Nano VNA. How many of you guys got one of these? Raise your hands. For 60 bucks, you should get one. I tell you, they are amazing. I require all my students to get one now. Get the one from R&L Electronics, the big 4-inch one. It's well worth the 4-inch one. That little one is more of an experimental one that they were working on. That's it's just not built very well. Spend the extra $20. Anyway, yeah, I'm working on a talk tonight because I teach that in one of my classes, how to use it. And someone says, oh, you should present it to hams. They would love that. And yeah, I'm trying to get it all together. Alrighty, anyway, so we're going to talk about our first talk tonight, and that's on the dual band J-pole that we did, 15 years ago. I'll give you a little history behind it, how we developed it, how it basically works without all the math and all this stuff, because we've done a lot of analysis of it. Just give me a show of hands. How many of you guys have one of our antennas? 2? Oh, that's good. That's good. Then we can sell you a bunch then afterwards. Good. That's good. Yeah, although it's really bad when I go, how many of you guys have my antenna? Everyone raises up their hands. Okay, end of the talk then. Goodbye. But oh, this is good. But anyway, this is how we raise our funds for our group here. And we do, I mean, it's fairly successful. I don't have any, I haven't had the only grant I have now is from County Com to develop some radio stuff. Otherwise, this really is how we raise our funds. So the antenna we're going to talk about tonight is pretty much covered in QST, originally 2003. A roll-up version of it was in 2007. Then they put it in the antenna volume 8 and volume 3 compendiums. And it's also in the ARRL VHF UHF antenna classics. So again, it's pretty well known. People can build it if they like. They can buy it from us if they like. It's not patented. So let's move on with this. So I do, oh, I see, I've got to do. So how do I, oh, okay, it works. Okay, this works. Okay, it still works. Okay, so here are the 2 articles originally published. The right-hand side one was the DBJ one, which is a base station version of it. And then, 3-4 years later, we did a roll-up version of it. And it really wasn't my idea. One of my students mentioned it and asked me whether we could do a version. Here's an interesting antenna pattern. We'll get into this later. What this is you recognize a figure 8, that's the vertical dipole. But the problem with a standard half-wave antenna of any kind, it will resonate at the third harmonic, which in the ham case would be UHF. But the pattern, if the top is the sky and the bottom is the earth, the ideal vertical dipole looks like a figure 8, which is typically what you want. But if you did it on the third harmonic, if you drove it with a UHF signal, the SWR would be reasonable, very acceptable. But if you actually start looking at the pattern, it looks like a 4-leaf clover. And what is only radiating in the horizontal plane, which is the earth. This is the sky, that's the earth. So you're sitting here, your transmitter's here, and maybe you're sitting here with your walkie-talkie. Well, only about 25% of it is actually back on earth. 75% of it goes up into the sky. So that's why you really can't use a single band VHF antenna like a J-pole at UHF. Not at least it wouldn't work very effectively. The good news is the SWR is acceptable, so your radio won't blow up. You won't do any harm to your radio, but the performance won't be optimum. And that's what we're going to try to achieve here. It's just how do you change that or modify it to optimize it, to try to get this green pattern both at VHF and UHF. And here is our latest article, at least in QST. That's the tri-band one. That's another talk we give. Then how do you get, when we did the dual band, a lot of folks are asking, hey, can you make a tri-band with 222? Because I know you guys have the Papa system down there, and you have the, I know we can talk to you on Condor. That's all on 220 up here. So we had this challenge of how do you make add 220 to it? So that's another talk that we can give, and how do you add it, and how we figured out how to add 220 on without any trade-offs. So I mentioned we didn't patent the antenna we're going to talk about tonight, the DBJ1. We didn't patent it because we didn't know about it. No, we didn't think that, I guess when we did it, I didn't think that there would be that many copycats out there. We just published it and figured, well, if you clubs want to build it, that's fine. Well, it turned out as soon as I put out that idea, within 1 or 2 years, we started seeing a lot of copycats on eBay selling them. And that was even okay. By the way, that was okay with me. If you're a ham, fine, go make it. The thing that upset me was, so we started buying them. There was like 3 or 4 copycats. They even call it the Ed Fong antenna. We bought them. Not a single one worked right. They just copied our dimensions from the original article. And I say in the article, these are dimensions for the materials we were using. Yours will vary slightly because of the velocity factors, the impedance of the material, and all that. There's the principles of it, but you got to figure out the details in your case, because stuff that we ship right now, we have to have all the wiring, all the twin lead. All of that is just custom made for us by Seminole Wiring and also Maya cables, because we have to characterize the velocity factor first. Otherwise, we're going to end up having to tweak every single one. And we do. Ultimately, the last 3 or 4% we can tweak, but we can't be tweaking 10, 15% variations. You're just too much time in that. So that's when I wasn't very happy when we started buying these antennas off of eBay. And one was, tuned to the weather band. It was like 158 and 160. It should have been ham. Some of them weren't using 300 ohm twin lead because they couldn't find it. Understandably, it's hard to find. They started using 450 ohms and yet use the same dimensions. And, most of you guys are pretty technical. You can't do that. One's 450, one's 300. And so that's why. So there was nothing we can do about it at that point. Nothing we can do except the attorney at the university, we talked to him about it. He says, it's too late. You can't patent. So that's the thing you guys have to learn. After you publish something, after 12 months, you can't patent it. It's considered public domain information if you published it. So it was too late to patent. But was Mike Kaufman. Mike Kaufman was the attorney. He suggested, well, the only thing you can do, so if you guys have read some of our eBay ads, we say, don't buy copies, buy it from the inventor. He wrote that. He says, you got to put something like this. Then you'll scare everyone else away and not buy copies and only buy from you. And it worked. I have to say it worked. But after that, we said, okay, Mike, we're coming to you next time we come up with an idea and we'll patent it. And it costs some initial homework and some money initially, but it protects you. But him being with the university, he doesn't charge us very much. It's very minor. But I think typically you're talking, what, $4,000 or $5,000 for a patent typically. So if you're going to patent something, you got to make sure it's going to make you money, unless you're very wealthy and you just want patents. So he wrote these. So that's why I think they say Mike Kaufman for the attorney. He was our attorney. He's kind of semi-retired now. Do they say here? Yeah. Mike Kaufman, right. They were both done by Mike Kaufman. So it was the tri-band one that we came out with later on. We patented it. And then how do you get gain out of a J-pole? We patented that too. So these days, we just have to patent things. I mean, I knew we patented other things at the university, but I didn't think these antennas would. But we understand now that you should. Okay, so when we started building antennas, we looked at it. Why would we choose a J-pole as opposed to a ground plane? I used to use ground planes when I was growing up. And yeah, I've been a ham for, how long have I been a ham now? I've been a ham since 1969, so 52 years. And had lots of fun, that's for sure. Made a career out of it, and I don't even see it as work anymore. Who said that? Was it Mark Twain? Who said that? If you find a job you like, then you never really have to go to work or something like that. Yeah, I wake up. If you see my lab in my house, it's just my hobby. So anyway, I'll tell you why we chose a J-pole. Ground planes have radials, and over my years of experience, I've had ground planes, and I bought the Ringo Ranger with radials, and they all kind of, if it's in heavy weather conditions, they'll all break off and they'll have problems with it. And a J-pole is also end-fed. We'll show you that in a while. And it's also very close to an ideal pattern. I think I have a picture of one here. See, here's a picture I took a few years ago. You go up to a tower now. This is, you guys are, on the West Coast, so you're probably familiar with San Francisco. This is Sutro Towers. This is where Twin Peaks, where all the radio towers are. Isn't it just interesting? I went up there a few years ago and took this picture. There is not a single, I can't see any, there is not a single ground plane antenna here. Not a single antenna in that picture has radios, because everyone's gone away from radios. So just notice there are no radios on any of the antennas. So most use a J-pole configuration like what we're going to introduce today. That design is, number one, it does not need a lightning arrestor. I think I say this, hang on, guys. I think I'll get it. It doesn't need a lightning arrestor, and we'll show you because it's a DC short. It has no radios. The only disadvantage is they're pretty tall. You notice all these are VHF and UHF antennas. They are pretty tall because it takes 3/4 wavelengths, and we'll get into this, to make a J-pole, while a ground plane is only 1/4 wave, but it has radios. And radios, you know, it's like, try to, although it's not as severe, whenever you have something sticking out, like a radio, imagine a broomstick, right? When you hold a broomstick at the end and try to hold it up, a mechanical engineer would call that R cross F. The force leaning down on you is quite a bit. And you can imagine if it's up on a hill like this, and we're talking, you know, wintertime, getting gust winds of, you know, 100 miles an hour. Radios don't hold up. So you really want to avoid them. It really puts a big wind load. So, and 50 years ago, they couldn't avoid them because you didn't have other designs available. But when the J-pole came out, at least when it started becoming popular, and when people were convinced it was a way to go and antennas do work with that configuration, you can see 20 years later, there's not a single ground plane in there, which is pretty amazing. I wish I had a picture of it, you know, 30 years ago. I remember I used to go up there when I was a kid. And ground plane was a standard antenna. It isn't anymore. Okay, so see, for example, here's a vertical dipole, picture of a vertical dipole, which typically, again, is not used. If it's a true dipole center fed, right, the middle of a dipole is about 70 ohms, so you can match it into, you know, 50 ohms. It'll be acceptable. So there's a insulator here. There's the plus part, and the braided part goes down here if you look very carefully. The problem is just having a vertical dipole here. You got to feed it, and you got to feed it at a right angle like this, so you don't disturb the pattern. And you still do, even at right angles, you disturb the pattern. And if you think you don't, how about this? You have to hold it up with something. If you're going to hold it up with a copper pipe, in this case, you use the copper pipe, it's going to act as a reflector. So the pattern will not be ideal here because you've disturbed it with this mask. Not only that, you've torqued it. You see this area right here? If you had your arm here holding it, you would feel the force. It's going to be pushing it down. So you need to make sure it's heavy duty enough with all the winds that this holds up. And it goes contrary to, when does this antenna work best? Well, this antenna works best when it's further and further out. Well, when it's further and further out, your torque, your R cross F is what a mechanical engineer would call that, will be higher and higher and higher. So what happens? You know, engineers have done this. They break. 80 mile per hour winds the first year, second year, 60 mile per hour winds. 10 years later, these fall apart. A configuration like this falls apart, and plus the pattern, right? That will always act as some kind of a reflector. So you see, they used to make these things with 4 bay, with 4 of them stacked. They used to put them at 90 degrees apart to try to get back to omnidirectional coverage, because you got to get rid of that pole. That if that mask is conductive like here, it's going to start acting as a reflector. So you got to make sure you need 4 of them, or at least 3 of them, to kind of get back your 360 degrees pattern. Well, hey, smart engineers can figure this out. That's just not a very good mechanical solution. So now J-poles are very popular and they work quite well. So so I first got introduced to this stuff. You guys might know Denny Monticelli. He's published a few articles in QST, and he's really good at DXing. He was retired as the chief technology officer at the National Semiconductor. But I knew him in the 1990s, and he showed this to me. I had never seen this before. I mean, I was in my 30s by then. Even I may have covered it in school when I went to school, but I didn't remember it. But he said, "Hey, Ed, take this home." He just had a ribbon. He just made this out of a ribbon chain. What do you think about this? First thing I noticed, a little longer, of course, 3/4 of wavelength, as opposed to just a 1/4 wavelength. And he says, compare this to your rubber duck on your handy talk. Yeah, I started playing around with it. Yeah, it worked quite well. It really did work quite well. And when I looked at it, because, we should take this concept and make it into a base station antenna. Then it'll be durable. He just gave it to me in a twin lead configuration. So for modeling and for testing, it's fine, but it wouldn't last. So I start sticking it into a PVC pipe. When you do stick it into a PVC pipe, of course, it changes the velocity factor. It's going to have to be slightly shorter. I compensated for that, and it really worked quite well. And you know why? It's a very simple explanation for why it's got to be shorter. The antenna is based on, C is equal to F lambda, right? The speed of light is equal to frequency times the wavelength lambda. And then that's how you get those dimensions for 19 inches for VHF, 6 or 7, 5 or 6 inches for UHF. A dipole at 20 meters is 33 feet. It's based on that formula. C is equal to F lambda. But C there is the speed of light equals F, it's the frequency you want. Then it gives you the wavelength. That's how, that gives a full wavelength. So if you want a half wave dipole, you cut that in half. But what it doesn't tell you is what happens if you put that antenna inside like a PVC pipe, because you want to protect it, right? You don't want the wire directly exposed. The first thing you notice, if you do this, you get an antenna working and you put it into a PVC pipe because you want to protect it, the resonant frequency will drop. You go, wait, I thought I just tuned this for, whatever, let's say 146 megahertz. Now it's all of a sudden resonating at 144. What happened? And then you pull it back out, it's back at 146. And you can confirm it happens, but why is it happening? It's quite a simple explanation. C is equal to F lambda. Very fundamental formula, simple as it is used by antenna designers. You cannot violate that one. It's the speed of light. In one case, in air, we're using 3 times 10 to the 8th meters a second. But if you stick the antenna inside the tube, it's got to radiate out. It runs into the pipe. And most people say, well, you can't travel faster than the speed of light. So it must be, if you ask someone, you think it's going to slow down the wave or speed it up? Well, it's going to slow it down. So you have basically the pipe, you have to determine how much it slows down. You don't use the speed of light is 3 times 10 to the 8th meters a second. You use something like 2.7 because it'll slow it down by 4 or 5%. I'll give you another example. The first time we tried this, when we tried to make antennas work underwater, we start out with a simple dipole. Turns out that the velocity factor, that's what it is, the velocity factor. It's how much it slows it down. So if people give you a velocity factor, sometimes VF is equal to 0.5. That means it travels half the speed of light. So instead of using 3 times 10 to the 8th meters a second, you would use 1.5. And sure enough, you're right. If you made a dipole and you have to dip it into distilled water, it can't be salt water because it's conductive, into distilled water, and you calculate the normal formula in air for it, whatever frequency you're using, you sink it in the water, it's about half the resonant frequency. So in PVC pipe, well, it's not as dense as water, it's just pipe, it lowers it by 3-4%. It slows down the speed of light. You put the antenna inside the PVC pipe, it's going to slow down the wave by 3 or 4%. So, we did this and it worked. And we've delivered way over 18. This slide was made a few years ago. We're about 30,000 right now. And, we make these for commercial. Hey, we make them for commercial ham. We make them, if you pay us, we'll make them for anything. That's what we do. That's how we raise our money. And we think for the simplicity, it's excellent. So back to this talk of how do you make a dual band? And I'll review the single band version. Uh-oh, what happened here? See, See, Dave, you took over my computer again. What happened, Dave? Oh, get back your audio, you're muted. Yeah, so I see you now, all of a sudden. Yeah. Yeah, try the share thing. Yeah, it's like I'm sharing your screen.
Dave, Tina came in and started. It says Tina is sharing your screen now.
Oh. So can you still see my slide? Okay, so. but you're the captain of the Enterprise. Oh yeah, what did you do? Okay, let me now I need to do it again, right? Don't I have to do this again, right? Like this, right? Yeah. There.
There you go.
Oh, but no. Hang on. That's not how we do it. Let's stop sharing again. Let's start all over. Oh. Okay. That's one of the problems with Zoom. All these little technical difficulties. If I do this, no, I can't do that. That's not what I do. I do this. Then I share. This here. And now you get back that.
There you go.
Right now. Okay. Now we're back. So let's go back to where we're, okay, cool. Alrighty. So basically I experimented with a J-pole. Works pretty well. And it's like early 90s, but by the late 90s and 2000, these J-pole configurations, the copper J's and a lot of versions of it started coming out, started becoming pretty popular. But not only that, simultaneously, another thing that was happening, dual band. Alinco, ICOM, Yaesu started coming out with their dual band handhelds, dual band mobiles. So I know, hey, no, you guys are pretty far from the TRW swap in San Bernardino, aren't you? Yeah, for you to go there now, but well over an hour, right? Yeah. But anyway, so we our big swap meet, it's called the Foothill Swap Meet. I don't know if you've heard of that. That's the big one here. We have it at different places, but it started at Foothill College, so they still call it the Foothill Swap. So we it's similar to your TRW swap. So we go to that. So all these folks with all these dual band handhelds by the early 2000s, hey Ed, I noticed these J-poles kind of work on UHF, but good matching, but performance-wise, we could tell it's not up to snuff. So I started looking into this, and it didn't take long. I started simulating and looking at how the antenna works and how is it working at UHF. Well, it turns out if you start simulating it on like EasyNet and we had EasyNet back then. Do we have ADS? We didn't have ADS, but it didn't take long before. Yeah, you're right. It'll lose about 6 to 8 dB. What it was that lobe here. So this is an EasyNet simulation, which I'm sure you guys have. Even in a simple antenna simulator, we'll show you this. A vertical dipole at 2 meters will look like this at the fundamental, if it's vertical. So this is the sky, this is the earth, and here's the horizontal. So you have your transmitter here, and you'll have you're standing here somewhere on Earth. So here you can see at the third harmonic, although the impedance is a reasonable match, maybe not perfect, but really reasonable match. I mean, if you really look at an SWR, put a VHF antenna at UHF, and you'll find it, it's under 2 to 1 almost always. But the problem is that's not the problem. The problem is the lobes. And if you really were to integrate it, you'll find that 75% of the energy is in these 4 lobes, and only 25% is left on the lobe that you want, which is on the horizontal plane, where you're standing here. I don't want to be standing here. If you want to see the optimum performance of this antenna, you want to be flying in a helicopter here. Most of us don't do that. Or this might be pretty good for satellite work, right? Because it sprays it up in the sky. But if you want to talk to someone on Earth, that's not the pattern to go after. So I started trying all kinds of things, started reading into it. And the thing is, it had to be pretty simple. You figured if I had to convert that 2 meters to also work at UHF, number one, it couldn't affect the VHF much, right? You can't tell people, oh, I know how to get your 2 meter J-pole to UHF. You got to do this. Then you say, but it won't work at VHF anymore. No, we wanted to make a dual band, very minimal trade-offs at VHF, and yet still have good high performance at UHF without this 6 to 8 dB of loss. Again, it had to be simple, reproducible. You can explain it to a ham on how to do it. And no fancy inductors. You can't have fancy capacitors. You cannot use capacitors for matching antennas up at UHF, right? For you RF engineers, you know, by the time you put a capacitor on a network analyzer like this at UHF, you have to model it with a series resistance for losses. The Q isn't high enough. It's not reliable enough. The variations, if you buy them off the shelf, 10, 20%, they've got temperature coefficients. That's not the thing to do. And I'm sure a lot of you guys have played with traps. Like I used to play with traps at HF, you know, trying to get more bands out of my dipole when I was young. You can barely get traps going very well at HF. To think you can get a trap going at UHF, you know, with capacitors and things like that, you might be able to get a few working for yourself, but to think you're going to publish an article in QST would be pretty difficult because it wouldn't be practical. They're just not, like I say, easily reproduced. So I tried all types of configurations. So I'll show you the one that we finally came up with. So again, the goal is, can you get this pattern at VHF, but also at UHF? Get rid of this pattern at UHF and make it look like this, so it looks like a half-wave radiator, both at VHF and UHF. Is that right? Okay. So anyway, I tried all kinds of things, and it comes back down to, you've got to know how a Smith chart works. You got to know how a Smith chart works. You know, I tell my students that want to get into antenna design, you don't have to know all about the Smith chart, because you're not going to be, if you're not going to be designing amplifiers. But one thing you do have to know, we use this so often, that on a Smith chart shows that if you have a short circuit on one end, if you go a quarter wave up, a quarter wave around, in this case, a quarter wave at UHF, 4 or 5 inches, depending on the material, it will read and open, and vice versa. If you have an open end, which is, you know, infinity impedance, if you go a quarter wave, it will be a short circuit. Guys that, yeah, it's interesting, guys that only know DC said, really? Yeah, that's why you can't do radio frequencies with a DC multimeter. You need a network analyzer. A network analyzer gives you that. It tells you this. In fact, do I have a stub here? Hang on. Let me get a quarter wave stub from the other room. Hang on. Alrighty. Here, went to my other lab room and got a bunch of quarter wave stubs at UHF. They look like this. This is just a piece of RG58 coax. So that's about 5 inches. And you look like, well, it's just a piece of coax. Well, interestingly enough, it's open here. If you were to plug this into the network analyzer, open would be an infinity. So if you were reference it here at one end, the other end, by the time you go to the other end, a quarter wave, it would actually be a short circuit, because that's how waves work. If you study, you know, electromagnetic waves, that's how they work. And again, if you go another quarter wave, it'll go back to infinity. That's where it gets, they say every half wave, you come back to the same point. That's where that comes from. Well, that's pretty handy. Surprisingly, that's very, very handy in antenna design, because they're quarter wave stubs. If you guys play around with antennas, whether it's HF or VHF, you actually do this quite often for matching and things like that. Sometimes, you can use this as a filter, right? You can actually use this as a filter, because if this is an open here, that must be a short at UHF. So if you happen to want to notch out a signal at this particular frequency, UHF frequency, you just put this in the parallel with your coax, and it will have a first order notch. So knowing that technique is pretty handy. We use it quite often. Okay, okay. So by that technique, let's go through how a basic J-pole works. This is made out of twin leads, so actually this is not used at all. Twin lead just convenient, the 300 ohms, even though now it's harder to find. But if you can find 300 ohm twin lead, but you can do this out of 450 ohm twin lead to it. The dimensions vary slightly. Oh, someone's at the door here. Hang on. That's my door. Who's at the door? Is it? Yeah, if it's Brian, just tell him to leave the stuff. Oh, my wife got it. Okay, so how does this work based fundamentally without the math? It says, here's a dipole antenna. Again, this is from a twin lead, so you can ignore that piece, just cut it out. It's 37.25 inch, 38 inches, depending what frequency you want. I should have, actually for the drawing, I should have made it 38 inches. And normally in a dipole, you would have fed it in the middle, just like that picture I have, right? That picture we have here. That's that piece right here. You would feed it in the middle. Well, we kind of discussed why it was so difficult mechanically to feed in the middle, and plus you would need a mass, and the mass typically will always reflect some of the signal, so the pattern would be distorted. You want the antenna in the clear. And how would you get in the clear? You get it in the clear if you can end feed it from the bottom, and then it sticks up. So this way you don't have to feed it in the middle. But the problem is that the end of a dipole antenna is a high impedance. It's no longer 72 ohms or 70 ohms. Oh, it's in the equivalently in the thousands of ohms. If we were to put an analyzer on it, oh, that's maybe not infinity, but it's pretty high. You need to find something that's high impedance to feed right in so that this whole thing could stand up in the clear. That's what a J-pole does. So how do you get something high impedance? Well, again, back to this quarter wave stub that we use quite often. That technique is so cool. And we're going to show you how to use it again later on. But just in this, the standard J-pole, here's the quarter wave stub. It's a short. You start out with a short. Remember, if you start out with a short, if you go a quarter wave up, it may not be infinity, but ideally it's infinity. It's very high, in the thousands of ohms. So if the end of a dipole is thousands of ohms, and the end of a quarter wave shorted stub is thousands of ohms, we can just interface it. In reality, you know what's happening. The wave sees a good match when you inject the wave in here. It'll be a high voltage point. It'll be like this high voltage, which is high impedance. You'll also see a high impedance from the dipole, so it just goes right through. So the wave would look like this: short quarter wave, that's the high, and then the half wave dipole looks like this. The voltage looks like that, like an S. That's how it matches. So again, you get a short here. The end's a high impedance. It matches right to this half wave dipole at the end. That's why I call it end fed. And if this is a short, and that's, you know, maybe like what I say, not infinity, thousands of ohms. I'm sure it's thousands of ohms. If this is a 0 and that's 1,000, there must be a 50 somewhere here. You know, 0 at one end and thousands of ohms at the other. 50s, in fact, that 50 is probably closer to the short than at the other end. And it is. It's about 1 1/4 inch up, 1 to 1 1/4, depending on the materials you use. Originally, we didn't use a model to figure this out. You just go get a network analyzer or just, hey, poor man's SWR meter, right? You just start taking these dimensions initially and then just start tapping and look at the SWR. That's one way of finding it. That's kind of a poor man's way of finding it out. If you're real consistent. And it turns out in 1 1/4 inch is about 50 ohms. So you can feed this at 50 ohms and it places a wave because it's matched. It's going to be 0 here because it's a short. The voltage would look low here and high here. That's exactly what you want at the end of a dipole. End of a dipole, you want high voltage because it's low current. And of course, in the middle, then the voltage wave would go like this, because in the middle would be low voltage, high current. And you've probably seen that dipole pattern before. So that's basically how the J-pole works with all the math. So here, a lot of people make them. Here's the copper J. So again, you can, whoops, here. Here's the half wave part. Here's the transmission line they've made out of the pipe. Here's the quarter wave matching line here. Here's the short, right? Here we blow it up, here's the short. And then somewhere, this is in air, so it's going to be a little larger, maybe 2 inches up, you'll see the 50 ohm point. You jump across there, and then the ground end is this end. You can flip them, by the way, they're symmetric. And we've played around with these a lot just to see. The main reason why I wouldn't recommend one of these is today you can't build that economically. It takes quite a bit of T's and elbows and the copper pipe and the end cap and solder and all this stuff. But if you do it right, it does work. We know because we build them. I have some of my students build these just to show them that you can build antennas that, or hams build antennas that look pretty ugly. Right, just face it. You put this on top of a roof on an HOA and people wonder, what the hell do you have on your roof? And it takes quite an explanation. And like I said, I don't recommend this because this is quite a bit of copper, by the way. Copper is expensive. You know, all these T's and elbows, and it takes quite a bit. Although it works fine. It works quite well. But good engineering practice says something can work quite well, but part of the goal is, does it work economically well? Well, economically, this antenna is, I think, too expensive for how it performs. The copper is just too expensive. But let me tell you some of the disadvantages of this one. Should this work at UHF? It should work at UHF because it's the third harmonic, except it doesn't work very well. The pattern is there also, but look at it. It gets too large at VHF. Remember, this is the transmission line. Now, you've made a transmission line, but that distance is a little under 2 inches from center to center. That doesn't make a very good transmission line at UHF. It's too far apart. It's a lossy transmission line, starts radiating. So that's one reason why I wouldn't use this antenna. At UHF, the transmission line is too wide, so it's very lossy. And because it's so wide, limited by this T and this elbow, to get across it, you need this almost a 2-inch piece of jumper. Well, at UHF, a quarter wave's already 6 inches, 5.5, 6 inches. You can't lose 1.5 to 2 inches jumping across in the wrong polarity, right? This is horizontally polarized. You're normally vertical. It's the wrong polarity and it's in the wrong spot. So this antenna, when you test it out at UHF, when you actually test that, works really poor, really, really poor, because it's the polarization is incorrect. Plus, you get the regular pattern of using using VHF on or using UHF on a VHF antenna. You get those lobes. So 2 meters is okay. By the time you get up to UHF, it's just a little beyond this type of configuration. Now, what's interesting is Arrow had an interesting twist on the idea of they understood that if you used a UHF radio on a VHF antenna, it doesn't work very well. One of their engineers came up with this clever idea, probably at least 15 years ago. I thought it was clever. You take advantage of the stub that you use for VHF, but it's the 3/4 wavelength at UHF, and then you add another stub, 6.5 inches for matching, because then you have two antennas. Here's the UHF J-pole, and here's the VHF J-pole. And it turns out that magnetically, you can feed them with just one connector. Does that work? Do we have one? Yeah, we got one. I like all these little clever. The good thing about studying ham radio, yeah, a VHF is fine. Yeah, I've got one right here. Right. It works okay. We've characterized this. And why do I get to characterize all this stuff? Hey, let me tell you a secret. After you've been teaching for 30, 35 years, you run out of research topics for your graduate students. Because they don't know any better, right? They're 22 years old. You just go, oh, go check out on this antenna. I'm not that excited, but they're happy. Really? Well, I go, what do you want to do? I want you to take some measurements on it, and I want you to get your ham license too. A lot of them become hams, my students. In fact, it's really funny. A lot of folks come into school, smart people, saying, where can I make a living? Where's the job market? Sometimes it's radio, 5G. They're just smart people. They could learn anything they want and they'll do okay, but they don't have the passion. Every now and then you'll get a student that, hey, I love this stuff. Well, Dave Vera was one of my students, probably 10, 15 years ago. He's one of the officers in our club now. Oh, Adrian, another guy. Yeah. So after you get hundreds of students, you have to kind of preach to a bunch of them, and then you're going to get a few diehards that come to field after a while. Yeah, quite a few of my students, they're field day, they come to club meetings, they hold officers, because you have to. You got to get the young folks involved in this. So I would say, maybe 1 or 2%, maybe 2-3% really become diehard hams, and they really love it. I mean, I know Dave, he's got quite a lab now. I mean, he's in his, now he's in his mid 30s, late 30s, but yeah, he's become a very good RF engineer. So yeah, anyway, so back to the story of how do we characterize, how do I find time to measure? The guy did his whole thesis on this antenna, why it works, why it doesn't work, what it's good for, what it's not good for. To me, I go, well, it's interesting, but they love, you give them work, they just love to do it, especially if they like radio. So what we found about this antenna was this. So the UHF portion is this part, right? Here's the stub, here's the radiator. The VHF portion is, here's the transmission line, kind of wide, but that doesn't seem to hurt, it still works. And here's the main radiating element. So when you plug in, here's the interface. When you plug in the PL259 here, if you plug in a VHF signal, VHF, this does not resonate. It's this part with this part. It works fine. It actually works quite well. The data that I saw that he had, quite comparable to our antenna. At UHF, it still didn't quite match up to ours. Because at UHF, this is the radiating element, here's the transmission line, and here's the matching stuff. So what's happening here? You only have one feed line coming in here. You have you have two paths that are matched. Obviously at UHF, it's this path. But the other half, you also have a good match from the VHF antenna, which is this part. So what his conclusion was, at UHF, half of the energy is going into the wrong VHF antenna. The other half is going into the right antenna. So you got to look at it this way. This antenna, one half of the energy is absolutely correct. The other half of the energy is partially correct. Remember, you lose 6 dB from it. So is this an improvement? Quite an improvement over the original design of using just a VHF antenna on UHF. Oh, you definitely notice it, but you're still missing that last 25%. Because remember, the UHF energy that went into here, 75% of it's thrown out. But that's only half of what your total energy was, because the other half did go into the right part. So that's quite an improvement. I mean, measurable improvement, noticeable improvement. Perfect? No, but quite an improvement. So that's a pretty clever design. So this design will not work at UHF. This one will. It worked fairly well. And they sell these, what, $60 or something like that? I'm sure they've sold a lot of them. Of course, the way I look at it, it's still expensive to make. Aluminum tubing and all that, it gets expensive. I think clever designs are inexpensive and good performing. And I think that was our goal. And that's why I think we sell so many. And the other configuration we see with this is the Slim Jim design. At least this term called the Slim Jim. Basically, a Slim Jim, when you look it up on the internet, what is the difference between a Slim Jim and a regular J-pole? Not a whole lot. They just connect the top together. They solder it, if it's made of twin lead, instead of letting this side float, you just solder it together. So in my original antenna here, instead of letting the side float, you tie it together. Which intuition tells me nothing happens, right? Well, yes, nothing happens, except that some group, I guess the Slim Jim group on the internet says, hey, you get 6 dB of gain. I think they mean 6 dB gain over a rubber duck. But you get that anyway with a standard J-pole. So I know Larry Seebeck spent a good last few years of his life trying to invalidate theory of the Slim Jim. He had a whole website, and these tests, I guess he had students too. They did tests on it. did simulations. There is no difference. So don't ever get fooled by, we have a Slim Jim that gives you 6 dB of gain. Yes, it gives 6 dB reference to a rubber duck, not to a regular J-pole. It behaves like a J-pole. That's all I can say to that. And I agree with Larry. Okay, what's this? Okay, so how do we dual band this? Back to this stub again. How do we make a dual band without having all the side effects? Again, that idea that you can short something, like here's an RG174 stub, you can short something here, short circuit, that if you go a quarter wave for that frequency, so 450 will be 5 inches, right? If it was 2 meters, it would be about 16 inches. If you short it here, it will be more or less an open there. The Smith chart says if everything were ideal, it would be infinity, but we can't really achieve that. As long as it goes really, really high. In reality, it just goes really, really high in the thousands and thousands of ohms. So what happens here? Let's go through this. You feed a signal in here, and let's go through the UHF one. Remember, I never said matching was a problem. VHF, UHF on these antennas, matching is not a problem. That's why everyone was fooled initially. Oh, I get good SWR. And you guys look like experienced hams. You want good SWR, get a dummy load, right? Dummy load gets you great. And if you can't do that, you don't have a good dummy load even. But if you have a good dummy load, it'll give you good matching. Matching is not the problem here. Because why? Simple explanation. Remember, for matching here, we said this is infinity. It's a quarter wave stub for VHF is about not 18, 19 inches, you notice, about 16 and a half inches in twin lead. So these are the things you have to remember. A short becomes an open for a quarter wave, and open becomes a short. And the dimensions of a quarter wave, half wave, if you actually build something, aside, if everything's all in air, you have to consider the velocity factor. You have to consider the material that wraps around it. In twin lead, it's the vinyl. In coax, it's the dielectric. You have to consider how much that slows down the speed of light. It's going to slow it down by 3, 4, 5%. Sometimes more, actually. It's actually sometimes about 20 to 30%. So in coax, it turns out, I'm sorry, in this twin lead we have here, this is twin lead here, it slows it down by quite a bit because it should have been about 18, 19 inches. Now it's like 16 and a half. So it's almost 10%, more than 10%. So the actual quarter wave, if you measure this on a network analyzer, it turns out to be about 15 and a quarter plus 1 1/4, or about 16 and a half inches. As opposed to 19, it's about 16 and a half inches. So again, you start out with a short, and a quarter wave later, it's going to be an open. So that will match to, open meaning high impedance, short and high impedance at a quarter wave at 2 meters. So what happens at UHF? At UHF, it's 3 times the frequency. It starts out as a short. So within 5 inches, the voltage, in the future, I'm going to draw the waveforms here. At UHF, the voltage is going to look like this. It'll come up, and stop at a quarter wave. That's about 5 or 6 inches. Then what happens? Well, there's an extra half wave left at UHF. It comes up a quarter. You're sitting here. And if you go a half wave more, remember that's fully around the Smith chart, it'll come back here. It'll come back around as a half wave S. And you're back at a peak voltage, which means high impedance. That automatically matches in. So you use up a half wave here at UHF, while at VHF, it's just a quarter wave stub. So it's what you call a 3/2 wave stub at UHF. But that's always the case, right? Like antennas, if you make an antenna at 100 megahertz, it will resonate at 300, 500, 700 at odd harmonics because it is 1/2 wave around the Smith chart. So you have to remember that. Every time you add 1/2 wave, you're back to where you were. Except for the minor losses, you've gone through about, at that point, maybe 10 inches of twin lead. I mean, it might be 0.1 dB of loss or so, but that's what happens. You get the peak voltage here at UHF, which is high impedance. And imagine if all you had here was the 11 1/4 inch or 12 inches, however your frequency is, you have the half wave here, you didn't have any of this here, the antenna will work great as a half wave radiator. You've matched it with not a quarter, but 3/2 waves total up to here. And then you see a half wave at UHF, it would work fine. If that's all you want. Now, if you want VHF also in this, and we already discussed that at VHF, this is a quarter wave stub. 0 volts here, and then if you plotted out the voltage, it'd be like this, dotted, and then up to here. It'll be the voltage max, which is the highest impedance point. So at UHF, you'll see this wave, and I'm going to draw this in a future slide with dotted lines. It'll look like this. The voltage print will look like that, and that will radiate as a half-wave dipole. But if you want also to work at VHF, you have to add on the extra, 37, 38 inches here. That's what this is. But you got to leave this out. For UHF to work properly, electrically, this has got to be cut out. If you don't cut it out, that's where you get the 4-leaf clovers. The current continues, and then you see these waves and you see these lobes. You got to get rid of this stuff. How do you get rid of it? Back to this C equals F lambda. Very important. You don't need integrals. You don't need Maxwell's equations and all this crazy stuff to understand this principle. You always have to obey speed of light is equal to frequency times wavelength. So again, you use a quarter wave stub. If it's a short here at UHF, 445 megahertz, if it's short here, go around the Smith chart, it's going to be about 4.25 to 4.5 inches for RG174. It's not 5 or 6 because that's the dimension in air. It's not in air. It's in the coax dielectric, right? It's inside this, right? In air, this would have been about 5 or 6 inches. A quarter wave stub in coax is only about 4.5 inches, 4.5 inches. So what happens here? At UHF, it sees it open. It sees an open. So if the wave comes through here, it doesn't continue. It sees an open, that's not infinity, but it's pretty high enough where I know this thing works. Mm-hmm. But at VHF, so that takes care of the UHF. At VHF, you still have the quarter wave stub, and then the whole half wave is this whole thing here, this entire piece here. So if you add up 17, 4.25, 11.25, it's going to be about 36, 37 inches, 38 somewhere, half wave. That's how it works. It's basically an electric switch, right? In a sense, you can call it that, an electric switch. At UHF, this whole thing gets knocked out, electrically at least. Physically, it's not there, but electrically, it's gone. Electromagnetically, it's gone. But at VHF, it comes back. That's how it basically works. Everyone following me here? Who's asleep? Wake up! Wake up! That's right. See, that's the problem.
I'm more or less following you.
I don't have an eraser. When I'm in class, man, I got an eraser.
No, so far so good. I'm following.
See, I don't have an eraser to throw at you guys.
So do you want to do a quick ask if there's questions?
Yeah. Okay. Is everyone clear how this works?
Is there anybody with questions? Unmute yourself, please.
Yeah.
Hey, Dave,
Flip. I hear Flip. Go ahead, Flip.
Yeah. Ed, I have a question. Does using a balun, a 1-to-1 current balun at the base at the feed point, does that affect any of the measurements in the J-pool?
Yeah, of course. That's a good question because that was the thing I came up with. Another good topic for young graduate students. Oh boy, more experiments to do. You know why they like these experiments? They go through too much theory. Hey, how many of you guys are engineers here? BSEE, MSEEs, or engineers in, right? Didn't you guys? Didn't you guys used to hate this? Maxwell's equations, feedback loop equations.
I still hate it.
So do I. So when you become a student and all of a sudden you're doing practical engineering, believe me, man, you can excite these guys with a little ferrite, with a little coax. When they see something like, wow, what are you going to teach me? Instead of some whiteboard stuff with all these Maxwell's equations and all this stuff, second order, third order differential equations and all this stuff. So, of course, we've experimented. Free labor. So Flip has a good point. So here is my conclusion about ferrites. Ferrites are used because you have common mode currents flowing back in the outer coax. Do you want that? That's not good. Especially if you have a lot, right? If you have a lot and you don't have a long coax, it gets back into your radio. And that's really bad because then it blows up your radio, and that's not what you want. So in that case, you put these ferrites. So we've done this. We've mismatched the antenna intentionally and put these ferrites. And Flip, have you used ferrites a lot?
Yeah, and I don't like them because they become saturated over time.
You better believe it, man. One time I touched one of those, I burnt my hand off. Oh, what does that say? It says you have a mismatch, right?
Yeah, exactly.
Obviously. The good news is at least you dissipated the heat on the ferrite. It's not dissipating in your radio where it's going to do harm to your RF transistors. That's the good news. The bad news is, why are you heating up ferrites when you're generating RF with 30% efficiency and modulating and all that stuff? If you want to heat a hot dog, go get a flame, right? You don't do it with a ferrite. Oh, I swear, that thing gets so hot, it will melt chocolate. It's too hot to touch. It is too hot to touch. So here's my theory on ferrites. You can always add ferrites if you want. It cannot do harm, right? It chokes all the reflective energy in your shielded or what's called your common mode currents. My philosophy is this, and I haven't seen anyone disagree with me. Why don't you just match the antenna with 1.2, 1.3 to 1? And then where does the energy go? Theoretically, if it's matched, it's radiating. Isn't the whole purpose of an antenna to radiate the signal? So I tell people, if your ferrite is getting hot, all that says is you have a bad antenna.
Right.
And what I've noticed is, if I operate my antenna, I'll challenge anyone. When you measure an SWR of your antenna, 1.2, 1.3 to 1, put a ferrite. It will not get hot.
Right.
It will not get hot. But if it's off, 3 or 4 or 5 to 1, it will get hot. Of course it gets hot. All the energy is being reflected.
Right.
So ferrites don't hurt you, but if you have a good antenna, they shouldn't help you.
Ed, one little last question. One little piece of question is, you made a comment that you can reverse the connection on the connection point or the feed point from the center conductor to one side versus the other. You can switch them. Does that affect the radiation pattern also when you switch them?
Not theoretically. If it's symmetric, it should not.
Okay.
It should not theoretically.
I always wondered about that because I've seen those J-poles wired wrong.
Yeah,
it doesn't matter.
It doesn't matter.
Okay.
We've tried. That's another experiment we did too, because the reason why this is actually, by the time the currents goes up through here, it wouldn't matter how you fed it. It doesn't matter. It's symmetric. It should be balanced by the time you get up there. It wouldn't matter.
Okay. Cool.
And we've tried that. It's true. It will not matter.
Good. Thank you.
So that's my theory on ferrites. Anyone have any comments? I mean, that's my theory. Does Mike have a comment?
I have a question.
Oh, go ahead,
Mike.
Sure.
Okay. You discussed early on what the disadvantages are of some of the other types of antennas, whether they're a dipole that's sticking out, and also with verticals with radials. What's the comparison in terms of looking at the J-pole versus a dual band vertical with radials? I'm thinking.
Okay, so the radials, a J-pole will give you, let's say a purely vertical half-wave dipole, which is what a J-pole is, will give you about 1.5 to 1.6 dB gain over a ground plane. You'll notice this. Build a ground plane sometimes, because we did this. We do all this stuff. You get these little simple things. I mean, you guys have been hams 34 years. This doesn't excite you. Get a 22-year-old that's they're learning all Maxwell's equations, Schrodinger's equations. All of a sudden, they want to become an engineer. If they wanted to become a theoretician, they would have majored in math. We do all these experiments. So back to the radials. So the radials come down. Well, if it's 90 degrees and even slightly slanted, you'll find that the angle of radiation is slightly higher because it's off a ground plane. So it looks more like a hemisphere. It looks more like a hemisphere. But a dipole, if you go for the dipole, not the ground plane configuration, what's pulling down the wave? You get this pattern. you get this pattern here. You actually find that this point. So what happens on a ground plane, you'll find that this point goes a little higher by, 6 or 7 degrees. Because what's pulling down the wave? It's just your radials. What's pulling down the wave in a half wave antenna? It's really pulling hard because it's vertical. It's pulling all the way from the other end. What difference does that make? About 4 to 6 degrees.
Wow.
It's not major, but you will notice it. Try it sometimes. It is measurable. 1.6 dB on a weak signal, you will notice it. We tried this several times. Definitely, the vertical J-pole as better receive and better transmit. That 1.5 dB, 1.6 dB, you do notice. It's not major, but you do notice.
Over the vertical ground plane.
Right. The other thing I don't like about the ground plane, why people don't use it, and by the way, this took some convincing over the years. Why do you have a lightning arrestor? You have a lightning arrestor because a ground plane or a dipole is an open circuit.
Right.
It's an open circuit so that it will collect, like if there's a lightning storm close by, just magnetically, even if it's not resonant, you get a 1,000,000-volt lightning storm. If you induce as much as 40 volts down you, how much protection do you have in the front end of your radio? It's about 40 volts. It usually won't take more than that.
Right.
But you notice on a J-pole configuration, it's a DC short. It's not, again, you have to understand impedance versus resistance. It's a DC short. So you cannot build up any charge on the center conductor. It's a short circuit, DC wise. While on a dipole, it's on a ground plane, it's open circuit. You do need a lightning arrestor. And I tried to convince these people years ago, a lot of people that use commercial antennas, I go, why don't you need a lightning arrestor? I said, you're wasting your money. Oh, no, we're not. Look, a whole idea of a lightning arrestor is that at about 40 volts, the gas is short, so you don't build up charge. Here, it's ideal. It's the ideal world. It's always shorting out. I mean, you go take your in fact, some people say, your antenna can't work. It's DC shorted. I go, it's DC shorted. It's not AC shorted. It's great. Yeah.
One thing I've always noticed about loop antennas, and essentially that's what this is, a shorted antenna has better receive because you have less noise. I
don't think this has any less noise. This one,
really? Okay, but just on band, is it maybe tighter tuning, better Q or something?
No, not this one.
So as far as you're concerned, dipole you think has equal receive to something like this, J-pole.
This is a dipole. This is a dipole.
It's a dipole.
It's just the way we're feeding it. It's just the way we're.
But you're feeding it as you have a short, so it's not an open circuit.
No. The dipole itself is up here.
Right.
This doesn't radiate.
Right.
This ideally does not radiate.
It's an end-fed dipole.
Right.
Yeah, it's just an end-fed dipole is all it is.
Okay, so it's just my imagination, I guess.
No, but it is end-fed and it is a DC short. So that's like the most ideal lightning arrestor you're going to get, right? It's always shorted except for the frequency you're operating on.
Okay.
So I think slowly we have convinced people that you do not need a lightning arrestor. This is better than any lightning arrestor you can buy. And I tell you, commercial lightning arrestors are like $100 to $200. And I said, you plug those things in. Come on, at UHF, you got 2 end connectors and a bunch of, there's a gas tube in there that shorts out. It's got losses. It's a physical device. This is sort of built into the antenna. But I do notice that people are finally being convinced that you do not need a lightning arrestor because, well, I guess it's the net code, electrical code that says you have to have it. And I think finally people are convinced, no, you just don't need a lightning arrestor in this case because they understand how the antenna works. Of course, they complain sometimes, like I said, you sent us a broken antenna. The thing's a short. And you know what I say? Why don't you try it out first? And then they say, how can this thing work? It's a short circuit. It works, right? But how? It's a short. No, you're mixing AC with DC. Or I tell them, my class is on Zoom. Sign in my class sometimes and you'll learn why this works. Or one of these seminars like what we're doing.
Right.
By the way, we cover this in one of my classes in my antenna design class. Okay, so let's go back to here where so we go back to, so you understand how this works now? At VHF, it sees the entire three elements, a 17-inch, the 4 1/4, and 11 1/4. At UHF, this becomes an open circuit or very high impedance. This gets knocked out electrically, not physically, electrically. So therefore, it only sees this as a half wave. So therefore, you get the half wave pattern at both VHF and UHF. And the stub here, this quarter wave stub, is a quarter wave stub at VHF, but it's a 3/4 wave stub at UHF. So, and then we have a version of that in a roll-up version, just a portable version. It's kind of tricky trying to get all this stuff working with heat shrinkable tubing that can all hold together. And then we have a RG174 cable with a BNC, so you can use this as a portable emergency antenna. So we came up with this article in 2007 or something like that. Actually, one of my students was a backpacker. He came up with, he didn't come up with that. He asked me whether I could do this, and we figured this out. So you do notice that between the roll-up version and the base, it's about a couple of inches difference, because one goes into PVC pipe and the other operates in air. You have to compensate for that.
Right.
So here's the actual performance on an 8591 spectrum analyzer. So here's a reference 2 meter, regular 2 meter J-pole at UHF. You're right there. Sit in the exact same spot. You replace it with one of our antennas with that little stub, and sure enough, you get back about 6 dB. Proof is in the pudding. And we've done this test several times. We even did it at Pacificon because I want to get believers out of people. Here, we've got the equipment right here. Here's the parking lot. You try it yourself. It actually measures about 6 dB. And what is 6 dB? Hey, 6 dB is quite a bit. That's like 4 times the power. Yep. 4 times the power. You know, your 1 watt handy, or let's say if you use the improper antenna, you may have a 4 watt Baofeng, and all of a sudden you think you're going to transmit at UHF with a VHF antenna. You basically have the equivalence of 1 watt. So yeah, it does work. And then here's some actual data. See, you wouldn't believe this talk I've given you. There's got to be at least half a dozen masters, what we call masters projects that are done on this. Because here was quite an elaborate project. How do you measure performances of 2 antennas? Actually, to actually measure the performance, you have to, one thing, you got to be in a clear field, but to actually publish data in it, typically you got to have 3 separate days that you measure this stuff. 3 separate days where you break down the equipment, set it back up. They recommend like a rainy day, a foggy day, and a regular sunny day, just to see what the differences in the measurements are. And then for each time you set it up, you need at least 5 measurements, 5 different measurements. This is the average of all the measurements. So there's 15 measurements here, the average. Foggy day, rainy day, and a regular day, clear day. So how does this measure up? And we're basically trying to just give you numbers for that. So I'll give you an example. A quarter wave mobile was a reference. This is just in a parking lot, by the way, on a weekend. So there wasn't very many cars. Pretty clear. I mean, it's going to be as good as you're going to get. Clear parking lot. Minus 24.7 dB was our reference. You know, it's like 50, 60 yards away, and we had a spectrum analyzer and hit the mic, and the thing registers about 24.7. And then we say, they call the guy, hey, replace that antenna now with a rubber duck. Sure enough, the rubber duck with no radios or anything, about minus 30.5. So about almost 6 dB of loss. So it is true. If you use a rubber duck at VHF compared to a quarter wave mobile antenna, it's about 6 dB down. So in the advertising, get a nice whip and everything, yeah, it does work better, measurably better. Now, if you use, and standing in the same position, use a standard VHF J-pole, no modifications, a standard, any type of, whether that's copper J or whether it's mine, it doesn't matter. But a standard one without the stub, it's about minus 23.34. Now, again, this is about 15 measurements average. So we believe these numbers are fairly accurate, you know, fairly averaged out. It's about, so yeah, it's actually, this one, it's comparable to the quarter wave mobile. Maybe a little better, but yeah, within a dB or so. And then, oh, I'm sorry. This is just a VHF only first. So it's comparable to the quarter wave mobile, maybe a little bit better, right? Because it's a VHF J-pole. It should be a little bit better. It's not much. 24.7, 23, over about 1.5 dB. That's exactly what it should be. And you use our J-pole, it's about the same. maybe a little less. And I'm pretty confident with these measurements because you've taken 15 measurements. It's about 0.1 dB lower than a standard J-pole at VHF. That's because we put the stub in, I think. It's something that's a little bit lost here, not much. 0.1 dB is nothing. Now you go back down here. Here's where you see the difference. This is a quarter wave mobile. Get the cursor back here. A quarter wave mobile, same location, about 50 yards out. That's a 5 or 6 inch mobile whip antenna. It's a minus 38.8. You put a rubber duck equivalent, and I tell you, ooh, the rubber duck we were using was about 3 dB off. But what subsequently I've noticed that you can get some really nice resonant rubber ducks. If you get the right one to match your handy talkie, it could be quite low. Maybe minus 1 dB or so compared to a quarter wave. It could be quite good if you do it right. If you get a spectrum analyzer, match different rubber ducks with your handy talkie, and like, you know, we found that I think it was the Anley antenna with a Baofeng really worked well. I mean, it was almost like a quarter wave antenna. So if you use a standard VHF J-pole at UHF now, oh yeah, it's quite a bit down. It just is expected 6-7 dB down. Because that's what you would expect. A standard J-pole, VHF J-pole used at UHF, you lose 5 or 6 dBs. And you really do measure that very easily. But if you substitute our J-pole, you get it back, right? Minus 45, minus 38, you get 6 dB back. You get about 6 dB back. That's exactly expected at UHF. So even with multiple measurements, it still shows that this technique does work. And fairly easy to implement. You just got to do it very carefully. Let's see what else. Oh, so that was our lab back then when we made these measurements. We used to use an 8753. These days, you can practically use one of these at these frequencies. By the way, we find that these are quite accurate. They're only good up to 1.5 gigs, but up to 1.5 gigs, they're quite accurate. I mean, this is a 6 gig analyzer, but we typically don't do that much up there. But at the frequencies that this is spec'd at, which is up to 1.5 gigs, it's fine. Oh, so here's an interesting question that people bring up quite often. So this stub, how confident are you of this stub working? Well, we have a network analyzer, a really nice one, in fact. Why don't we just measure it? So sure enough, when I sweep this stub from 30 megahertz to 1 gig, it kind of wraps around. Oh, it's here. I'm sorry. Low here. See, low frequencies just looks like an open circuit. It wraps around. But at 445, it's right about there. Again, remember I was saying it's very hard to get infinity. It is not infinite. It's a shorted stub, quarter wave, but it's nevertheless pretty high. That's 50 ohms. That's 0. It's pretty high. High enough where I think it makes good performance for what we're doing. I'm sure if you used LMR 400 or something like that, it would be even higher. But we just happen to use RG174, and then for our high power version, we use RG8X. And I noticed that it's pretty stable. If I take that stub and put my hand around it and everything, yeah, it goes all over the place, but not at 445. It's because it's resonating. It's pretty stable, very stable. And I also looked at it at 146. At 146, it looks like an open circuit wire, pretty close to one, because a wire looks like that at 146. So yeah, it may not be exactly a wire that's stub at 146, but it's pretty close. And that's why you get these performances that say that its contribution to losses, it looks like a little bit, 0.1 dB or so, 0.115 dB, not significant. Certainly a good trade-off compared to getting 6 dB back at UHF. So here it is, see? This is mounted on the side of my roof. It's N-fed. When something's N-fed, it is tall, but you don't have any, the force is just vertical. You don't have, when you have radios sticking out, you have a lot of torque associated with it. And especially with the PVC pipe, it's all round. And we notice that the wind just kind of blows around it. Even when the wind blows, this thing doesn't sway that much because it's all round. If it was square, that'd be a little bit different, but it's all round. Keep everything round, and wind just goes around it because it has low wind load. Here. So here's the roll-up version. What we do is, here's the antenna all in a roll-up form, and we terminate it in a BNC connector, and then we include these adapters, BNC to SMA male and SMA female. And then we also have again, one of my students suggested, hey, you should have these extensions made. It's a 6 feet RF extension with a BNC male with a BNC female. So you just kind of cascade it like an extension cord. And, you know, you can connect 2 or 3 of these and you're still okay. You know, you start connecting too many, the losses get pretty high. But if you're camping and you want to throw the dipole a little higher, 2 or 3 will get you about 20 feet and still performs quite well. Let's see. So here is another talk that we will give. This is how do you get gain out of a collinear of adding a half wave delay line. And this will give you about 3, for every time you double the elements, it'll give you about 3 dB gain. I won't get into details here. That's another talk. And then my other talk is on how do you get 220 tri-band out of this antenna. So we've built on this basic concept of how to make a dual band. And some radios, we don't sell these, but like the Baofengs that go tri-band. Yeah. These radios are pretty good. Have you guys bought any of these things, these B-Techs and these Radio Oddity?
Yeah, I've got one just like that.
I think they're pretty good now.
Yeah, they're improved definitely.
Yeah, I think a couple of years ago when they first came out, I didn't have any that were. I think I may have had one that was bad because we give these away at our club for raffle prizes.
Right.
And I think now they're very reliable. If you buy from Radio Oddity, they're very reliable and they're very nice people. You can return it and they'll pay all the postage, and also just send you one. They said, "Don't worry about it. Here's another one." They like any company, they've gotten really good. And the B-Tech ones are the same, basically the same design with a different software. I don't know. It's debatable which is better. It's different. Maybe a little more user friendly on the B-Tech, but it's basically the same radio. But I bought a lot of these for raffle prizes. Yeah. The UV5R, but the ×3, the tri-band, those don't seem to have any problems.
They're great radios. I've got one of those. It's a great radio.
Yeah, during Christmas time, they were selling them for $22.
Yep.
I bought like 5. I buy a lot because I need them for raffle prizes when meetings start up again. And for $22, and then of course I've got the code plug. Yeah. All the 220 megahertz and 220 UHF repeaters here. I program it up before we give it out. That's what people want the most.
Yeah.
Oh, yeah. I mean,
the radio without being programmed is pretty worthless.
Oh, I keep, I've been working on my database, especially my DMR databases. I'm constantly updating them, because they change, right? New repeaters, they change PLs. So to give a prize with it all ready to go, people love that because it's a real hassle trying to program all these things.
Yeah.
Yeah, so these are selling for $22 during the Christmas holidays. Jeez. I was amazed. I don't know how they make it for $22. And, these for $99, a 2-meter 22440 200 memory channel radio. I tell you one thing, they give ICOM and Yaesu and those guys a run for the money. That's for sure.
Yep.
And then I got involved in this, and we just got involved with their latest radio too. Do you guys have any of these at GP5s?
No.
Oh, that's a pretty cool radio. It's by CountyCom. You can look it up on their website. They had a contract with the government in 2012 to make a handheld radio, completely handheld, that their spec, I think, was 200 hours on penlight batteries, but it had to receive single sideband, CW and AM on shortwave bands, had to be synthesized, fully synthesized, dead accurate, had to receive AM and also FM. And as a bonus, because of the chip we bought, it'll also do the long wave stuff, 150 to 520 kilohertz. It's all software defined, uses a pair of 22-bit Delta Sigma A to D and D to A converters, and it's got 450 memories.
Wow!
But it does single sideband pretty well. We made sure it did single sideband really, really well. Upper and lower sideband separate.
That's a neat little receiver. That's pretty cool.
It is. It works really, really well for what it is. I think it works quite well. If you guys want one, I've got a few left. I don't have very many of these left because we did this and they gave us a couple of cases of these radios. So if you guys want them, they're $65. Otherwise, I think they're $99 on their website. Yeah, you can go to their website and they have a demo. It receives really quite well. The heart of it is the Silicon Labs chip. These guys have just done some major innovations in radio receivers. They start doing TV tuner chips, and then they found that there was a market for general purpose SSB radios like this. So that, and then otherwise that's the end of my talk.
Okay.
If you guys want to buy these antennas, Dave, I can send you a spreadsheet. You can spread it around.
Okay.
And the $32 if you buy it through the club. Not normally 32, they're 40.
Right.
If you buy it individually, obviously all the paperwork I have to charge 40. But if you could do a club purchase, we could do $32. I'll send you the spreadsheet. You can send it out to everyone, and I just want a summary sheet.
Absolutely. Yeah, well, we probably will have interested people. Sure.
Yeah, and there's no rush. Believe me, we get a lot of customers. It's amazing how popular this has got among the commercial world. We supply now. You guys are probably familiar with ADT alarms. ATD alarms has got a mesh UHF network now. They don't use phone lines anymore. Mesh network of the alarms, and you can't imagine the hundreds of antennas they use. Hundreds. Wow. Typically, if it's a neighborhood with a lot of them, they can get away with a rubber duck in your garage, a little transceiver. But if you're in a remote area, then they have to put an antenna outside. Well, I don't know if it's all of our antennas, but they certainly buy a lot from us.
Wow, that's cool.
They use the UHF gain one. They came to us. Actually, it was from a grant, probably 10 years ago now. They had this mesh network going. What it was is because the old ATD alarms, they use your phone lines.
Yeah.
And when I talk with the guys, this is ridiculous. We're ATD alarms. We use a phone line. The guy sends us, we bill them, each customer, half of that money they give us, we got to give to the phone company. So probably about 20 years ago, we can't have this. We've got basically $15 a month or whatever. Half is going to the phone company.
So basically all the subscribers are part of the mesh? Is that how it works?
That's right.
Yeah, that's very cool.
So they started getting, they got 10 channels from the FCC. They're at UHF. Some of them are at 455, some of them are at 465. And the transmitters are 2-watt transmitters and receivers.
Wow.
And when you, I don't know if any of you guys have ATD, go look in your garage. You see it. It's a little radio. And it's a mesh that talks to the next radio. Typically the rubber duck will, do a mile. They'll do, it's digital, they'll do a mile. But some people are too far away from another node, so they need an outdoor antenna. So I don't know who else they buy from, but they buy a lot from us because they came to us to develop one. Their spec was, can you make a reasonable gain 4, 5, 6 dB gain antenna? No radios. They wanted no radios. That's pretty durable, not too big, that you can make for about $50 because they were buying comets and diamonds and they're about 80 to 90.
Yeah.
And I said, yeah, we'll try this. So it turns out, the one that I will show you, and the gain, that's where I got this idea, is how do you get gain out of a J-pole? Yeah. That's where that came from. It was a grant from them.
Wow.
And yeah, we sell it to them for like 40 now because we can make theirs so fast. We've gone down the science of making those. They order within a week, we can get them out. And we sell them for $40 a piece.
Nice.
So you'll see these around your neighborhood. So they put them in places where the customer is too far away from another node.
Right.
So this way they could go farther.
Do they just put them on top of the house somewhere? Or?
Right.
Yeah,
they use LMR 400. I've seen their setup.
Yeah.
LMR 400 end connectors, and then it's up in the roof.
So it might be an issue if you have a CCNRs or whatever.
No. I mean, when they tell them it's for an alarm, I mean, the antenna is only about 3.5 feet in white PVC. No complaints. My thing is, why do they allow satellite dish antennas?
Yeah, they have to.
That's huge.
I know, it's huge. It's ugly. It's way more ugly.
Yeah. So anyway, that's the end of my talk.
Okay, well, gosh.
Any questions?
Hey, Ed, I just have one. What are you working on now that's really revolutionary, that you're really trying to solve? Anything that you can talk about?
Don't go too long.
Futuristic? Yeah, futuristic.
If it was revolutionary, why would I tell you?
No, I mean something that's tickling your brain, something you're thinking about, or something that's unique, whatever.
Well, I'm working on one thing. It's a problem that I don't have exactly solved yet. Here's a problem that, again, in my younger days, the last major project we worked on was on satellite antennas for Eutelsat, and we did some work with Space Systems Loral. We did the Cirrus Logic antenna, but I'm 66 years old, and we've got plenty of money. My students have got plenty of money. We don't have that problem anymore. That's when we were really looking for big grants. So that was our last big project, and then this GP5 thing we did for County Com. So we don't. If you're asking for grants, no, we don't have any. But I'll tell you a problem I am working on. Kind of interesting. I'm working on it with my daughter. My daughter is a master's in mechanical engineering and has a certificate in electrical engineering. And this is the problem we've been working on. We have not quite solved it yet. and I'm not sure there's a solution. Here's a problem I get a lot from hams, especially. Can you make an antenna? Just an example. A lot of hams want to also operate MURS, you know, the 151, 154, and we're at 145, 146. And you say, you can have two separate antennas, no problem. I can make, like what I've shown you here is a dual band antenna, but one's at UHF and the other one's VHF. The tri-band antenna is 220 in VHF. It's not on the same band. It's not in the same band. And have you ever tried this? Have you guys ever tried to do two resonances? See, what happens is if you study this, if you have one antenna resonant here, one antenna resonant here, they're separate antennas. Let's say they're close. Let's say again, let's take the problem of ham 145, 146 megahertz. And the guy also wants to operate MURS 154 or so. Can you make a real lossy antenna and have the SWR low? So I tell these folks, oh, well, I can give you an antenna with real low loss and good matching, but not low loss, but high loss, but good matching. The extreme of that is a dummy load, but it won't work. So you say, okay, I have these two antennas, one resonating at 146 and one resonating at 154. Have you guys ever tried to bring them together? In other words, if you, I'll give you an example. If you, parallel dipole, okay. You try to parallel two dipoles, but they're close in frequency. Obviously, you can make banded dipoles at 80 meters, 40 meters, 20 meters. People do that. I use one. But what happens if you want to make a dipole at 40 meters, 7.2 megahertz, but you also want to broadband it to 7.3 megahertz? That's pretty hard to do because at some point, they kind of just combine into one. In other words, you won't see two resonances. You'll see the average of the two.
Right.
If you ever notice if they're too close, they won't separate. All of a sudden you bring them close. So you see this two bumps, and all of a sudden you come close because they're close, but yet they're too far apart for one antenna. And at some point they just start blending.
Right.
If you've played around with antennas, so that's why it's very hard to get one feed point antenna to resonate at two frequencies that are very close together, unless each antenna is like a really high Q. You know, two resonant cavities for repeaters or something. Yeah, you can do that. They both have to be really high Q. But if they're low Q at some point, they start blending.
Right.
So there's a real high demand, apparently, for 2 meters and also resonating with the same antenna on MURS frequency. So we're talking about 146 and then 154. So could you do that and see clearly, you know, two bumps?
Yeah, interesting.
I've tried several ideas, but the same problem comes about when you come that close. All of a sudden, the thing just resonates at 149. They blend together. They're not far enough apart. But again, what we find is unless both of them are really, really high Q, and you can keep them apart. But if that's the case, then they're too narrow.
Yeah,
I don't know.
There's going to be a gap between them.
Yep. You guys have probably played with this. This is the same problem that folks have on 80 meters.
Yeah.
For
It's such a wide
80 meters,
band, such a wide band.
It's too wide band.
It's too hard to tune the entire band. It's impossible.
Yep.
to tune.
Yeah. You end up, well, what I tell people then just, your best bet is just have a wire tuner, right? Have twin lead coming down. You basically have an 80 meter dipole there, basically, and have twin lead coming down to a wire tuner.
Yeah.
And this way you can kind of move around. Not optimum, but it's as good as you can get. I know the ARRL says you can cage it, use a cage antenna, you kind of have multiple, like a fanded dipole of different, slightly off. They say that kind of works, but I think I just tell people just come down with 450 ohm ladder line and tune it.
I've seen people do that for the counterpoise. They make different size link counterpoise and put them together. Sometimes
but if they're too close, they blend.
Then it'll blend, right?
Yeah. If at each band, then clearly you can see these resonances. But if you bring them close together, you put in an antenna analyzer. They just at some point you don't see the two bumps anymore, and they just kind of make one bump. So I don't know. That's one thing I would like to solve. I know a problem you can work on, Flip. You know what our major problem is?
Hey Ed, I wasn't asking for a problem, Ed.
Are you trying to apply to grad school here?
No.
We got a lot of problems. Our major problem is how do we manufacture more of these antennas faster?
Yeah.
Need a factory.
Yeah, you got to
Well,
have a
I got
factory
a-
someplace. Yeah,
Hey,
you gotta
we've got a factory here almost.
yeah.
I try to keep this place so neat. It's a constant battle because I can't make anything at school.
Yeah.
Oh, that's
If I
interesting.
do,
Yeah.
it's got to go through the school. They got to cut 15% off the top.
Yeah, I hear you. Yep.
Everything is made here
Wow.
in my dining room. I'm still
18,000 of them, Ed.
That's right.
Wow.
Oh my
I haven't
gosh.
made them anywhere else yet. Well, actually, we do a lot more than that. We are doing, well, I'll tell you guys, we're doing about out of my dining room table, we're doing about $250,000 a year.
Wow, that's pretty good for antennas and ham radio and even commercial. That's very, very good.
That is good.
It's gone way beyond my expectations.
Yeah.
I swear, I really have two jobs in my life, teaching and doing this. I mean, this, the good news now is I don't have this commute I have to do.
Yeah.
So I can stay up pretty late. I can stay up to 1:30 working on this stuff and still wake up at 8, be at my desk working by 8:30 because I just put on my sweats and I'm there, right? And believe me, you save an hour going there, that's 2 hours of your day. You can be very, very effective with 2 hours.
Not to mention, you're in control of your own destiny without all the political garbage to go with
That's
it.
right. That's right. So in a sense, this COVID thing, it's got advantages and disadvantages.
Right.
The disadvantages to my students. It's hard teaching online.
Yeah, it's very true.
It's really tough.
Question.
They really get shortchanged. They pay the same tuition, by the way.
I think we have another
Yeah, I
question.
know.
Yep. Mike.
Question. What is the physical length of the tri-bander versus the dual bander?
Oh, only 6 inches. That extra 6 inches is to add the 220 coils.
Wow.
It is taller, yeah.
6 inches taller.
Yeah, I think it's about 5. The tri-bander is about 5.5 feet right now, while the dual band is a little under 5 feet, about 4 feet 10 inches.
All right.
12 inches or so. Yeah, it adds about maybe 8 inches. About 8 inches taller.
All right.
How much does the tri-band antenna weigh?
A little under a pound.
A little under a pound. Okay.
Yeah, so it's really light. These things are really, really light. You do this thing right, you can make it out of cheap materials. Light, you can make it durable. You certainly can go with copper pipe, but it's heavy, it's expensive.
No.
But you know what, Ed? The price point you have on that is so very reasonable. Why would you even bother to go buy the materials and try it yourself and do all the tuning and everything else? Your price point is
You're not
very,
charging
very
enough,
low.
I think is what flips.
Yeah, that's exactly what I'm saying.
Tell you what, we can make it special for you. You can pay us. We won't shy away from that.
Well, Ed, we really appreciate your
Thank you.
It was
talk,
fantastic.
and
Very
we'll
good.
probably be interested in having you come back sometime.
Yeah, book me. I'm
Be
pretty
appreciate-
booked until the end of the year now.
Yeah,
But yeah, we can schedule in, and we can talk about the tri-band or the gain one. Either way, the gain one's got an interesting story with ATD alarms.
Yeah, this is interesting. Very cool. I like
you
the
guys
mesh.
can build it yourself.
I like the mesh idea. Maybe we had set up our own little internet mesh here.
Well, do you guys have high speed ham networks down there yet?
We've got Arden. We have the Arden net.
Is that part of the?
It's not really
see,
high
so we-
speed. I don't think it's.
Well,
high
we have a
speed.
network here that uses the 2.4 gig ham band. Do you guys have that? We use
yeah.
the Ubiquity
5
routers.
We're using 5 gigs mostly, but yeah.
Oh, but you use 5. Okay.
Yeah. We've got some on 2.4. I think our local. We've got a local mountain repeater. I think it's Snow Peak that we can connect to with Ubiquity router and connect to the Arden mesh.
Oh, that's cool.
Yeah.
Okay, that's good. Yeah.
So it is local. It's not really easy for me. I have to go too high, and I have too much wind here, so it doesn't really work well for me. But it does work well for a lot of people that have.
Yeah, we're
that
trying to
are
get it
line
all
of sight.
going here.
Yeah.
But it is difficult. It really is difficult to get the range.
Yeah.
With the
It
Ubiquity, you got to be line of sight at a mile at the most. You get out of that.
Right. It's got to be
You're not
right
gonna
on
get it.
target, especially if you use the
Yeah.
dish, because the dish is really, really tight focus.
Yeah, it's
So-
tough. I have mine on top of my roof, And I keep on telling people it's always on. When you hit it, give me a call. I haven't had anyone hit it yet. Yeah, it's very tough. It's very tough. It's not that easy.
It's interesting.
But eventually we'll get it going.
I'm interested in that stuff for sure. Okay, cool.
Hey, so you guys normally meet Thursday, right? So
we normally do have our meetings on Thursday night, but we
thank
could
you
be
for
variable.
changing it because I had a
problem.
lab last night.
No problem.
Okay. Hey, you guys have a good evening. Thanks a lot for giving me your Friday night time.
Thank you, Ed, for your
And I probably
time.
interrupted your dinner.
No. This is our normal meetings time, more or less, just the wrong day.
Very nice presentation, Ed. Very, very nice.
Very good.
And very knowledgeable.
Thank you very
Cool.
much. Thank you very much. Okay.
Great.
So how do I sign out here? How do you see all this stuff here?
Stop participants sharing.
I go like
There.
that. Yeah, then
I
I can.
took you
Okay,
out.
73s.
All
You
right,
guys
take
have a
care.
good evening. Good weekend.
See you later. Take care.
Yep.
So I guess we're going to go ahead and finish our meeting here.
Hey, Dave.
Yeah, Mike.
I'm very interested in some of those antennas. So if you can get that price list, and you can try to put it together as a one order for the club.
Absolutely. DJ, are you still there?
Yeah, I'm here. Can you hear me?
Yes, we can hear you.
Yeah.
Could you
I'll
put
I'll
something
get
together?
in touch with
Get the
when I get
information
back.
at least, and we'll
When I get back
coordinate.
with them, I'll get the
Okay.
emails and get it all set up.
I would appreciate that.
Okay.
Yeah,
I've already got my shopping list right here.
So we already have. We may
Yeah.
end up making him work hard. So he's going to be in his living room making antennas for us.
You know, Dave, I bought one of these antennas.
Uh-huh.
I bought the DBJ1 for $32.
Is that the dual band?
Dual band.
Yeah.
I love it.
It works
It
great.
works perfect. Well, two things he didn't comment on that he specified in the presentation I saw. One, the PVC pipe you use to contain the antenna
Yeah.
and not be Schedule 40
Ah.
PVC.
Oh, really?
Right.
It has to be Schedule 200.
What's the difference? What's the
Thinner
difference? Pete?
wall. Thinner
Oh,
wall.
okay. All
You
right.
need the thinner wall stuff. And I wanted to paint mine to make it less visible instead of having white PVC up there.
Yeah.
And
You can't do that either.
his statement is painting is okay if you don't use metallic paint and only put one coat of paint on it. They tested putting 2 coats and it tunes it off.
It changes the velocity factor.
Yeah, it changes.
Cool. Yeah.
So those
Very
are
cool.
points.
Pete, when you get when you ordered it, it does not come with the PVC. Is that correct?
No, the PVC I think is $3 for a 10-foot length.
But does it come assembled? I mean, is it already tuned and everything?
Everything is all set. All you have to do is take his twin lead assembly and slide it into the PVC.
Oh.
And he gives you 2 PVC caps, one for the top and one on the bottom that contains the connector.
Right.
He already has a connector drilled and mounted.
Oh, I thought he shipped it already as a packaged unit. You know, already. Put
Everything but the
together.
PVC. And
No PVC, yeah.
Oh, okay.
But otherwise, it worked great.
so you just have to cut it to length then, basically?
The PVC you can make, mine is 5 feet long.
So you just, I mean, you can make it as long, you could just cut it to however long his antenna is. Yeah.
Yeah.
Okay. And then stick the caps on.
His antenna is like, I don't know, 42 inches or something long, something like that. Maybe 48. I don't know.
Well, I'm interested in I would be interested in the tri-band.
Yeah, I would
may,
do.
I may go back and buy the tri-band now.
Yeah.
Yeah, you'll have to get a radio to go with it.
I know.
It's nice to have. It's so nice to have one coax for 3
Thanks for
bands.
spending my money.
One coax for 3 bands is a great economy measure. That way
Yeah.
you don't have to have as many wires coming in. It's very nice. Okay, so we're going to skip the Pledge of Allegiance because I think we're past that at this point. So let's see. Jeff set out the minutes. So, did everybody look at that for last month's meeting? We actually have our meeting on YouTube, so if you want to look at it that way. So does everybody want to, can we have, is there anybody, let's see, how do I do this? I'm so bad
I'll
at this.
make a motion that we accept the minutes.
Thank you, George.
You're welcome.
Do I have anybody that would like to second the motion?
Second.
Bill will second it.
All right. Is there anybody against the motion? All right. Thank you. The minutes are accepted. Mike, give us the treasurer's report, please. Mike, yes, Mendoza, you're muted. Let me fix you. Did you get it? Hold on. I can't unmute you. You got to unmute yourself.
Push to talk.
I don't know why it doesn't let me unmute him. It just says ask to unmute. There we go. Okay.
Yay.
You're ready. Mike.
Okay. We got $6,120.90 in the bank.
So we've had some people actually send in their dues. That's good. So if there's anybody that forgot to send in their dues, you're past due, guys. Come on, send it in. I know that it's a lot easier to hand it to them at breakfast, but, you know, it costs what does it cost now for a stamp? 60 cents or something?
55 cents, I think.
Yep,
Yeah.
55 cents.
55
It's still
cents.
55, yeah.
So, you know, send Mike your check, please, so that you'll continue to enjoy our club, if you haven't done so already. And let's see. Director at Large, DJ, you still with us?
I'm here.
What's your plan for next month? Anything?
I don't have a plan yet, but I'll get one.
Okay. I don't know. Is anything else going on that you want to? It's your time.
No, I'm glad Ed was here because when I got here to the desert, I had no cell phone service, and I had an email come across, and he said Saturday, and I kind of freaked out for about 20 minutes trying to get a hold of my wife to give him a call and say it's not tomorrow, it's not Saturday. It's Friday. And luckily she got it. And he goes, "Oh, I messed up the date. And we got him.
Oh,
so
good.
I knew he was going to be here. Just going to take a little bit to get him on, I guess. But I'm glad he showed up. Definitely a good presentation. I enjoyed it.
I think so too.
Very good.
Hey, Bill, how's it going with scheduling that control?
I have no problems. Everybody has met the commitments, and I'm getting good reports from our past president, and so I really have nothing to add. The usual recruitment. If anyone who is not a net control now and would like to try their hand at it, we more than like. I'll put you on the schedule. Just let me know.
It's great practice for operating. So you guys, new guys that don't get to operate a whole lot, you should volunteer so you get to try it out. You get better at using the radio because you're forced into doing it on a regular basis and coordinating our nets, which is sometimes tough. Let's see. VE testing, Pete.
Yeah, we had a VE test in January. God, I don't even remember how many we had. We had like 5 people, I think, took the test. They all passed. One guy was a general. He took the general. Everybody passed. And then 2 of the technicians took they took the general test and failed it. Both failed it. But they gave it a shot. So It was pretty successful.
It was unusually. It was a long morning for the VEs, so I really appreciate everybody that helps with that, especially Pete because he's the wrangler. But everybody that's a VE and helps with these things deserves some applause. And then Aries, how about Mike? Is anything going on with the Aries?
2 weeks ago, they had a meeting, an organizational meeting to talk about what kind of training they want to try to do for the next year. And they're supposed to have something come out. They're supposed to have some training coming out next month, and I'll keep you guys involved as soon as I get any information.
Okay, sounds good.
I have a question for Mike.
Go ahead.
The Skywarn training, did I already miss that, or hasn't happened yet?
The 16th of March.
Okay, so I have not missed it. Okay,
You
good.
have, no, you have not missed it.
I'm glad because I was certified in that at one time, and it'd be good to be recertified.
Yeah, that's.
Maybe we should send. Maybe we should put something together and send out an email regarding the Skywarn training, right?
Yeah, I've sent anybody that's a Races member has already got it.
Oh, okay. So the races send out the emails. They send out the emails.
Yeah.
Okay. And Steve, that reminds me. Steve, are you there? NJ6LN?
No, looks like he left.
He's disappeared. Okay. I was going to have him talk about races. We'll skip it this time. And PASCOM. Anything happen with PASCOM, Sam?
PASCOM, not meetings.
Nothing going on?
No meetings.
No meetings. Okay.
Races, we did some training on satellite radios. They have two installed, one out in the desert and then one back in Riverside. That would be at the location if we have a problem. And not a whole lot on with that. I still haven't, I did find, for some reason I had in my head that maybe Joey wasn't at the hospital anymore. But when I went over to give blood the other day, why security came by and he's still there with the show. So.
Oh, good.
The things stay the same, and the antennas are still up. Haven't fallen over yet. And then we're still, Mike and I are still doing the mesh thing every Monday using our equipment over at the alternate EOC. And I say our equipment, which includes the club and Mike.
So when you say the mesh thing, you mean you check in on the chat,
right.
On the mesh chat.
Mesh thing. And then some guy named DJ shows up periodically and update everything for us so that we're dialed in and tuned in and running right. The only thing we got to work that Mike and I need is I need some tweaking and finishing up on WinLink.
Oh, okay.
They used to do it and it was pretty good. I can do it all up, but for some reason I'm having trouble getting it transmitted on out.
Well, I'll tell you what. If you need me, I'm available. Just let me know. I'll come over there. No sweat.
Periodically, we leave the printer on as you suggested, and I would say 75% of the time or so, it works fine. Once in a while, we got to go back and
turn it off and on or something.
And
reboot the computer. Yeah, reboot the computer. Yeah, I believe the printer is a slave to the computer, so the computer could cause problems as well.
But it's working good. Print's
Good.
clean, nice, and neat. We test it every week.
Perfect.
So,
well,
we still have the Races net on the Sunday morning at 8:30 on 3.945. With that, and periodically, I think Mike's a little closer to it than I am. Michelle comes down with some stuff for him to do. She likes him. He stuck his hand up once. So with some of the stuff that EMD is doing.
Oh, good.
And I got my second shot today.
Oh, you got your final COVID shot. Cool.
Yep.
Did you have to go to Riverside or something?
I went to
the hospital. Oh, no, India. Okay. Oh.
I had an excuse to get out and drive and have a good time.
Jeez.
Hey, Mike.
Yes.
Yeah. Mike, I understand the Sun Lakes is having COVID shots available.
First and second.
Yeah.
Can anybody sign up for that?
As far as I know, you have to just register ahead of time, but it's first and second, and I guess there's limited amounts of vaccine, but they won't say exactly how many.
Yeah.
Yeah.
It was my understanding they're only giving first shots.
They were. Yeah, you have to be 65 and over.
Yeah.
And
that's not a problem.
but I'm not sure that. I'm not sure that if we have people coming from outside. I don't know about that.
Oh, that's what I was actually asking.
Yeah, I just don't know. Yeah.
Walgreens is doing it now.
Who?
Walgreens?
screens at both stores.
Whoa,
Right up on Ramsey.
Ramsey, and also up on what the hell ever that street is, Beaumont Avenue.
No.
Okay.
Oh,
wow.
Okay.
Riley Parsley.
Rite Aid's doing it too.
Wow. Okay, interesting.
Down by you on First Street or Second Street. Second Street.
Second Street. Hospital was doing it too, weren't they, Ron?
Yeah, we're doing second shots tomorrow.
Oh.
So if you have a badge,
I heard, I saw, I tried something different. I went in the other arm this time. I didn't want to.
didn't want to swell up again.
Ron had.
That's
Mine
what I did
swelled
too.
up after a week.
I took shot number 1 in the left arm, and I took shot number 2 in the right arm.
Yeah.
And I actually didn't have any reaction other than a little soreness for like 6 hours. That's it.
I got very, very sick on my second shot.
I'm doing an informal survey. You got sick, Pete. Did you take the Moderna?
Yes.
Yeah, everybody that I've heard that gets sick on the second shot is taking the Moderna. So I think that's the one. I took Pfizer for both of them and never got sick.
Well, maybe that getting sick means it's working though.
Maybe.
How do you know? How do you know it? Anyway, okay, well, okay.
One of the guys here in Four Seasons, he went to get his shot, and she said, "Which arm do you want it in?" He said, "I don't have enough meat. Give it to me in my butt."
Ah, did she do it?
Yeah.
That's funny.
Oh, darn.
Now, Pete, thank you for the explanation as to why the second shot is
yeah, I
connecting with
didn't
the
know
first
that.
shot
Yeah.
and stuff.
It's very good.
Yeah, I hadn't heard that. Thank you.
Yeah.
Interesting. Okay, guys. Well, unless somebody else has something they want to bring up.
Just a quick comment.
Sure, go ahead, Mike.
Whatever we got from administration, they did not indicate which they were going to be giving here in Sun Lakes, whether it was Pfizer or Moderna.
Oh,
you're right. They did not.
I thought I heard it was going to be Pfizer.
Oh, I hadn't heard that. I don't
Let me
know.
look and see if it says on
I don't
my.
know.
Did you got the actual? I'm sure Mike's on the list, and you got the same thing I did, the direct email.
Yeah, but Mike's right. They didn't say which one it
No,
was.
they didn't say. I think you're right.
probably whatever's available.
Yeah,
Probably.
we're scheduled for Wednesday to write it in Redlands.
Maybe you'll get the new one. That this should be either finalized tonight or tomorrow sometime.
Yeah, Johnson & Johnson. Yeah.
That quick? Is it that quick finalization? Really?
Is that the one that's one shot?
Yeah.
Is that,
Yeah,
And,
single shot.
And refrigerate only, no freezing.
I'll be darned.
Oh, interesting.
Yeah,
So therefore that was going to be they figure going to be at the outlying distance where they can just take it and just keep it in the refrigerator. You don't have to have special freezing and stuff.
Yeah.
anything on field day?
March, April, May. Yeah, it's only three months out. Yeah.
Gosh, we haven't actually. Maybe we need to do is start a field day planning committee, huh?
Well, I think DJ's got some insight.
Is ARRL sponsoring field day this year?
I can't imagine that they're not.
Yes, they are.
They are?
They are sponsoring it. They've even got field day.
Have some paraphernalia out already.
So, yeah, they've got stuff out. So I'm not sure what the configuration is going to be.
Yeah. Are they still hinting about the lockdown type of thing, or in your home versus out in a group?
That's what I'm thinking.
I think they were going to do it the same way.
Really? Wow.
Yeah. And when they're opening up quite a bit though for keeping distance.
Yeah, right. Opening up like crazy. I don't know why we just can't do the same old field day that we've always done.
Doesn't seem like it would be very unsafe, being as we're all outside.
Yeah.
And always apart from each other anyway. But
yeah,
it would really, last year we did do it, and we just didn't have any visitors basically.
Yeah.
You know, all the radio waves are going to kill the virus.
Yeah, it's hopeful.
Just stick a ferrite on the bottom of that J-pole. Melt the chocolate.
Or get Jeff to turn up the amplifier a little bit.
If there's anybody that's interested in helping with the field day planning, I can tell you right now that unfortunately DJ is, even though he's not here to defend himself, he's going to be required to be part of it because he's our
He's
our.
here.
Oh,
He's
is he
here.
still? Is he DJ still here? Good. DJ, you're required to be part of it because you're our field day manager.
I will have to check the calendar, but I believe I'm going to be missing field day this year.
Oh, you got to
Really?
miss the day. Oh.
Yeah, I missed. I was here for this one this last year. I
It's-
think the
it's
year
his-
before that, I know I was gone. So
His wedding anniversary falls on field day.
Oh.
It's really bad planning, DJ.
yeah, had I known.
Yeah, right. Yeah, right.
We'll
I love
put
it.
together a committee. We're going to have a committee, but it only really means a couple, 3 people. It doesn't have to be a lot of people, and we need to plan where we're going again. I'm all over Dysart Park myself. I love that place, but I'm open to other places, and I like the idea of assuming we're not in this pandemic mode. I really like the idea of doing it in a place where there are more people just around that might fall upon us. Even in that, we saw that to some extent, but not maybe.
How about at Ocotillo Wells, DJ?
There you go. That might get DJ more interested.
It is state land, so I don't know. It'd be a little hot in June though.
Yeah, it could be pretty rough.
I know an old gas station in Jacumba.
They moved it.
Well, I tell you what, I'd like to do it is do one of the, like, try to duplicate what the club did 50 years ago or something when we were doing our field days over up on the communicate just is it, my directions are bad. It's just west of Beaumont. There's that mountain there where I guess there's already some comm gear and stuff, but they did it there. But they also went out to gosh, where was it? I can't remember the name of that city. Where the homestead was.
Right.
Yeah, out in Yucca Valley area. That's obviously ridiculous. Can you imagine our club driving everybody going to Yucca Valley to do field day? That just seems crazy.
And Yucca Valley in June too.
Yeah, it seems crazy, and then doing it in cars that were, as primitive as they were back in the 40s. Yeah.
There's also a hard time getting to Calamasa.
Yeah.
There's also Bogart Park.
There is Bogart Park. And actually, that would be a pretty hot place. That'd be a pretty good place to do it. Why have we never done it at Bogart? We can't spend the night.
Mike, we have done minimum, right?
We've done Bogart Park.
Have we done it? Okay, I've never participated.
I think at one point in time we were competing with another club for Bogart Park. too.
Desert Rats.
Yeah, the Rats.
We slacked off and they took over.
Okay.
Yeah.
They're still going. They're not going up there now, though, are they? I don't think so.
No, they're staying out in the desert down at the hospital or somewhere.
Maybe that's a possibility. Bogart Park sounds really good.
I think we did it 2 times.
It's a good location.
And also, there's a lot of shade on Bogart too.
Is that run by county or is that run by
The city of Beaumont.
I
think it's the city.
Bogart is county.
Is it county?
Hold on, guys.
I stand corrected.
It was recently taken over. I forget what agency took it over, and they have redone that park, the pond, and all that.
Oh, really?
And I don't know what agency took it over.
Huh.
We'll have to go up and find out, huh?
Yeah, and we may have to figure this out because we have some pull with the county because we're with Racy's. We're part of Racy's. Maybe we can, I don't know, leverage that. So if it's county owned, if it's city owned, we got pull there too because of the EOCs and everything. So
Because the county gave it up some time back because of expense for some poor reason.
Gotcha.
There's another possibility too, is there's that Seneca Park. I don't know what the exact name of it is, but it's in Beaumont, almost across the street from Four Seasons.
That's the place
Yeah,
where
right.
where we did the practice field day one time, or we did like QRP testing or something in that park.
Yeah, that's a nice spot. That's a really nice spot.
It is a nice park, actually. It's not the greatest elevation wise.
No, no.
But it is out there, and it's kind of public facing. I'm not sure if we need any kind of permit for that.
I don't know. We'd have to find out.
Yeah.
Also, we've got to see if they would allow any overnight.
Yeah.
Yeah.
Yes.
Is that a city-owned park, by the way? I don't know. Does it Beaumont own it?
Which park is that?
The one by your house, Pete.
Yeah.
Seneca Springs?
Yeah.
Yeah.
I think that's city-owned.
It is.
Unfortunately, we don't know people in the Beaumont City Hall right now.
Oh, we know one person.
Well, we know somebody.
We know some people? Okay, good.
The former mayor.
Well, I like the idea of having it local, and even more accessible than Dysart Park, because Dysart Park's kind of, you know, it's not where there are a lot of people. You have to drive there. I like the idea of having it somewhere where there are just a lot of people, so that we might get some passerby, traffic or something.
Seneca Springs is not going to work. They have soccer games there on weekends. That's not going to work.
How far is Bogart Park? I don't even know where it's at.
It's up at the top of Highland Springs.
Oh, okay. All right.
I just looked it up. Bogart Park is now under the auspices of the Beaumont Cherry Valley Recreation and Park District.
That's what I thought.
That's new. All right.
I didn't remember, but that's what I thought. I kept thinking it was local.
Gotcha.
Pete, what about the area up by the playground? Not in the playground, but up in that area where you and I have been. Would that work and not interfere with soccer?
Yeah, but it's just not big enough for all the antennas and the whole. I don't think we'd have enough room.
You know what AJ6LN or KJ6LN would say? I can still get. He has connections over at Coombs Junior High School over there on almost to 8th Street on Wilson.
Actually, doing it in like a high school, something like that might work.
I mean, that's not really it's a school, but it's not. I don't think there's that many students there really. I think it's like
You mean like at Beaumont High School on Brookside up in that area?
Yeah, something like that.
That might not be bad.
If we can get the permission.
There's no shade there.
If we can get permission, that's the key.
Well, hell, we could do it at Ukaipa. They wouldn't care.
Well, that's true, and we actually have some pull there. But that's a bit of a drive. It's not that bad. We could do Ukaipa. That'd actually be a pretty good idea.
Hey guys, I gotta run. Catch you all later.
Okay, Flip. Take care.
Nice meeting. I'll catch you later.
Okay, well, I guess we're going to have to put into new business, creating a committee for the field day, and we'll start on that right away. Does anybody else have any ideas or questions or comments before we hang this thing up? All right, thanks, guys. Thanks, everybody, for checking this out. And I think this is a very interesting topic, and it was really a fun meeting. So, and we have it all on YouTube. That email that I sent out that shows actually has the link. If you click that, it'll go to the playback mode, and you'll be able to watch this again if you're so interested.
I didn't understand it all, but it sounded like the end was good.
Yeah, I mean, it sounds to me like they really have a smart design, and they're just using a simple thing like a little short piece of coax in order to detune part of it, so only part of it resonates at the lower frequencies, and that makes for a better dual band antenna. It's pretty cool.
He contacted us about 4 years ago.
Is that right? Okay.
Put it out to the board, and
what we need to do is maybe we should consider buying one for the club, or at least maybe update our antenna at the EOC or something. It's something to think about.
we might set him up like every other month.
Yeah. So I guess maybe we should have a board meeting soon. We could talk about that. Maybe I think it's generally a pretty good idea to periodically buy new antennas anyway, because they kind of go bad after a while. having one that tunes 3 radios and with one coax is a big, that's a big help. Even if you're using separate radios, you can always go with take a tri-band or a triplexer and turn it around. We can run 3 radios off one antenna.
Well,
so there's lots of neat ways to do things. Anyway, we'll just look at that as a possibility. But yeah, and we have many people interested in the club. If we'll do a mass purchase, whatever.
way back when, I had OUJ build me a J-pole tri-bander.
Yes.
2 meter, 220, 440.
Was that the one that has like 3 different connections to the 3 different antennas on one? I was going to ask him if he tested those. I bet you. I wonder. Did you ask him about that?
What's that?
Was that Bill?
No, I'm just saying I actually have. I don't know. Maybe OUJ made the antenna that I have. It's a tri-band copper J-pole with 3 separate feed lines and 3 separate coax runs.
And he had. I couldn't get it for a while because he hung on it through the Hamfest at Palm Springs. Because he had it down there showing it off.
Yeah, so that's just basically 3 J-pole antennas just stacked on top of each other.
Yeah.
And somehow it works. What's interesting is the smaller ones are on top, but the lower ones are using the smaller ones just as part of the
and I
the overall length.
I have that mounted on my roof.
Uh-huh.
Periodically, if I'm having trouble with the Comet, I can switch to the J-pole, and damned if it don't work.
Yeah, J-poles are usually excellent antennas.
Hey, Pete, did you get that, what was it, Schedule 200? Did you get that at Home Depot?
Yeah.
Yeah.
Okay.
Them or Lowe's, they both have it.
Yeah. Okay. You could probably get it at Do It Best, too.
Probably can.
It's common stuff.
It's common. Low pressure. Yeah.
Yeah.
It's easy to cut.
Yeah.
So you don't need special tools.
Yeah. All you have to do is cut the 10 in half and you got it.
Okay, Ron.
Bye, Ron.
Bye-bye.
So
Ron. Take care, Ron.
What's the diameter of the pipe they're talking about? Is it 1 inch? Is that what it is?
3/4 inch.
3/4 inch? Okay. Interesting. So they give you the caps, so you gotta make sure you get the right
They give
pipe.
you the end caps.
Yeah, you gotta make sure
One
you
of
get
them has the connector on it.
Yeah, but his caps are already set for the. They're already set for the connectors. They're already.
They got a connector. They got a connector on one of the 2 caps.
Right.
And then you just put the pole over the whole antenna, plug it in, and then put the other tap on the top. So you got it. Basically, the antenna's completely waterproof then, and it would be even better if you actually use like RTV or something on the ends, so that you have a watertight
that's
seal.
interesting. Interesting, you should say that because it comes with instructions, and in bold type it says, "Do not seal the end caps. To avoid the warranty."
Oh, because it'll flood or something, huh?
I don't know why.
That's interesting. I wonder why.
It would build up humidity and cause problems.
It could be humidity or even pressure or something too, I suppose. I don't.
Hey, Pete, how do you hang the antenna inside the coax?
Oh, you don't have to. You just push it in. It's rigid enough that it'll stay.
Ah, okay.
I had that same question. I thought maybe you'd have to have a hanger inside, to hold it up. No, it's staying. It's okay. You don't need anything. I thought what you were just going to ask me was, how do you connect this 5-foot length of PVC to an existing PVC mast? How do you connect the two?
And the answer is?
I saw that as a problem. I think I came up with a good way of doing it. Because you have end caps on them. So that tends to hold the 2 masts apart, the antenna and the mast. And when you clamp it, it could cause it to rotate or twist. But if you take, I had 3/4 inch hose from Home Depot, reinforced pressure hose, and I cut 2 lengths of it about 10 inches long, and put them between the mast and the antenna. And then I put 2.5-inch clamps, hose clamps around the both, and tighten it down on the hose, and it squashed them and holds it solid. So it's working really well.
Guys, I gotta leave. I'm going down in flames here.
Okay.
So-
I'm getting tired myself. Take
Yeah.
care. Take care.
I have one thing, Dave.
Go ahead, Don.
The Calamasa group is testing March the 11th at 5 p.m. at the St. Albans Church on 5th Street in Ukaipa.
Okay.
If you know of anybody. We've already got 2 extras and a general that signed up.
Great.
So
could you send me a,
did the batteries get all distributed?
Yeah, Don, everything got distributed except for Joe Vecca. Haven't seen him yet.
Okay, because he said he may be getting some more.
I know you
If anybody's interested, let me know, and I'll see if he can't say something for you guys.
Those batteries are really nice. I don't know if you saw the email that went out from Jeff. 12 volt, 7 amp hour batteries. They're only a year and a half old. Some of them are less than that.
right? They just
Was 12.8 volts.
So they are really in good shape. I tried charging them up. They're perfect.
Sam, you had your finger up?
Yeah. I've got 3 of them. I've had 3 of them for a long time. And I go out on events and they'll run my 8800 all day long.
Oh, good.
Just put them in parallel.
Yeah, just hook the 3 up in parallel, and they're easy to pick right up, set right down by the radio, and it's. Then if I was gonna
He
take,
doesn't know when he's going to get them, but if he gets them, if you guys want them, I'll let you know. And
Yeah, let Jeff know, and he'll send out another email.
That's
Yeah.
the best deal in town. Those batteries.
It is a good deal because those things are expensive and they're hard to have them shipped because they're so heavy.
now, Pete, if you want, I'll get a hold of Joe. Maybe we'll get together and find out when one of us can pick his up.
Yeah,
All
yeah,
right.
yeah. I got it sitting here.
Okay.
I have one extra battery out of all those you gave me, Don. So if anybody wants one, I have it. You can just let me know.
Cool.
I want to say bye, guys.
Okay, take care,
Okay,
DJ.
bye-bye, DJ.
All right. I think we're going to call it quits anyway.
Yeah.
Are you headed out to the campfire, DJ?
Yep.
Yeah.
I noticed your dress. You look like it.
Is it cold out there? Yeah, of course
It's
it is.
not too bad.
Not too bad. Oh, good. All
Bye-bye,
right.
guys.
Take care. 73.
73.
Take care, guy. Thanks for everybody coming. Enjoy.
Yeah, good meeting.
Appreciate it. Take care.
Thank you.
All right. Thanks for everybody that checked in on YouTube. And we'll do this again next month.